Okay, so this is what he had for chapter 0. And I imagine this is actually the content from it, so we'll like recreate it. Let's get an overview of what we got going on. Let's do... Okay, awesome. Yeah, I'd love that. There we go. Okay, so this starts off with an engine. See how nice that is? Really easy. Let's get a review of each of these files, and then we'll start going through the recreation process. And let's shrink down so everyone can see the code. And let's bring this over. Okay, good enough. Okay, so it talks about init, cleanup. Okay, let's get this formatted. I guess, is it using tabs? Yes, because everyone is an asshole and they love tabs. Okay. All right. And that's just SDB image. That's the definition for Vulkan engine. VK extent 2D. VK types, okay. Vulkan init code goes there. Add our main reusable types there. Okay, cool. Good setup. All right, let's see what we got. All right, this is the new version of the guide, so I'm kind of curious if other people did the old one. Oh, let me get links so folks can follow along. All right, chapter 0, setting up the guide initial code. I'll look through it and maybe it's already done. We're fine. So Vulkan initialization and render loop draws a flash and clear color. Vulkan compute shaders and drawing. Use a compute shader to draw. Vulkan mesh drawing. Draws meshes using the graphics pipeline. Textures and better descriptor set management. And then full GLFT scene loading and high performance rendering. Okay, cool. That's quite a lot. Hey Vinit, how you doing? Give me a second. Very few people use Vim and Windows in a combo. Do you use Windows to be able to play games, or do you use it as a main development system? I use all three. Well, I don't use Mac much anymore. After I swapped it to the other side of my desk, I just got lazy and didn't plug it back in. So I'm just going to sell it. But I use Windows because the people I teach use Windows. That's pretty much it. And honestly, they're all terrible. I think pretty much every OS is just really not usable these days. So I use, this is actually Linux, and this is Windows. So what I do is I kind of just make everything the same. That way it's kind of more consistent for me. Introduction to Vulkan. Vulkan API provides a list of function and return type. It's a C language and should be compatible with the vast majority of languages. So I'm really curious to try to redo some of this with Nim and sort of like see if like how Nim makes it easier or harder. Vulkan is significantly harder to use compared to OpenGL. Mobile market. I don't care about mobile market. Okay, and when we run Vulkan powered apps, we're going to run 2 core render paths, as the alternative will be at the cost. Okay. For desktop? Okay, I don't care about phones. Validation layers is an optional feature in Vulkan that detects and reports incorrect usage of the API. Okay, that's kind of cool. Validation layers work by intercepting your function calls and perform validation on the data. If all data is correct and validated, a call to the driver will be performed. Next project, make OS the hard way. I thought about it. It's, you know, I think there's like a set of like, you know, I want to say like core projects that I think everyone should try. You know, make a programming language, make an operating system, make a game, make a desktop app, make a web app, make a network server. So if you do those like 5-6 things, then you pretty much learned all the different things that exist in programming and can branch out from there. So at this point, the only one I haven't done is yeah, operating system. Okay, cool. Usage and general mindset. The Vulkan API, almost everything designed around objects they create manually and then use. This is not only for actual GPU resources such as memory buffers. Internal config. At some point, I do really want to make my own language. Making a programming language is probably the most straightforward and logical thing in programming. Yeah, I always feel like programming languages is the core theory of computer science. Everything else is just something using programming languages, right? So I've always thought that if you want to like get good at programming, the first thing you learn is how to make a simple little compiler. Nothing fancy, but if you know how parsing works and how parse trees work and how compilers work and all that, then you can sort of like do almost anything after that. Because if you think about it, a hell of a lot of stuff is just really just a programming language. So take like GPU programming, SPIRV, all the GLSL, HLSL, they're just programming languages that compile down to kind of an assembly language. When doing actual GPU commands, all the work on the GPU has to be recorded into a command buffer and submitted to a queue. Okay. Start encoding things on it, and then you execute it by adding it to a queue. All right, that makes sense. Submit a buffer into a queue, it will start executing on the GPU side. You have tools to control when that execution is finished. There's no concept of a frame in Vulkan. This means that the way you render is entirely up to you. The only thing that mattered is when you have to display the frame to the screen, which is done through a swap chain. So you like render some stuff and then you put it on the screen. Okay. There's no fundamental difference between rendering and then sending the images over the network or saving the images to a file or displaying it to the screen. Okay. seems totally reasonable. All right, next, the Vulkan render flow. Hey, Velen, good morning. Oh, are we doing Vulkan today? We are. We're comparing the Vulkan API. Everyone says it's harder than OpenGL and it's terrible. So you can see, like, how do I feel about the Vulkan API? But so far, I think OpenGL is just a pile of absolute dog shit. It's so badly designed. We're like, oh, first you make a buffer, and then just do stuff, and it shows up in the buffer. Like, no reference to any buffer. It probably has no ability to be threaded at all. Hey, Squid. 55. Welcome back. I wanted to make my own one too, but most new languages are just the same thing in the end. Revolutionary languages. Yeah, it's not hard. Like the very simplest way to do it. I mean, if you want a quick rundown, like ultimately get something like RE to C, or like you just do it quick, right? RE to C, or get Radgel's good too. If you learn Radgel, you pretty much that's everything you need. That's your Lexer. And then you have two choices. You can write a recursive descent parser, which those are really easy, but hand-coded parsers tend to have bugs. But you go get the lemon parser. Lemon parser generator is the one that's used in SQLite, and it's very easy to use. You give it your thing, and it's just simple little C. A lot easier to use than Lex and Yak, I find. But, you know, if you want to go old school, then you go get Lex and Yak. Or Bison. There's like tons of tools that are very easy to use. Lots of guides for them. Bison, GNU Bison is another one. Alright, so there you go. That's your Lexing, then your parsing. Then you need to output a binary. So there's you could go lib lightning. It's really easy to use. Where's that? GNU Lightning. So this is basically a kind of a just-in-time compiler, but it should be able to, yeah, and then you just use this to make your virtual machine. That's it. So then you learn how to use the Lexer, right? How to feed those tokens to a parser. And then when you have your parse tree done, you learn how to convert the parse tree into byte codes with this thing. It is literally just a bunch of defines over cross-platform assembly language. It's about the grossest shit you're ever going to see, but it works, and it's very, very fast. And kind of gives you a sort of like an intermediate start. And it does generate real bytecode assembly language, so you can actually like do really simple CFFI, like all kinds of stuff. And that's kind of your start. It's not that hard. You can also do an interpreter. So then the other direction to go, if you want to do all hand-coded, which is actually kind of harder, but you just get like any regex library will do. Yeah, so go to regexer and work on your regex. Any regex library to match on things. Then you write a recursive descent parser. Those are real easy to write. They're also very easy to fuck up. So, if you learn how to write out your grammars like this, it's a little bit easier to code the RDP. Then once you have a parse tree, so you have like your abstract syntax tree, then you can write an interpreter. And so the interpreter just walks the abstract syntax tree and does the code. In some ways, you can make interpreters faster than virtual machine stuff. But interpreters will never really be faster than like a compiled language. So if you do those, then you can go the hardcore route where you get into LLVM and all that stuff. But I think what happens when programmers are trying to... So I think what happens is programmers go, oh, I want to make a programming language. I know what I'll do. I'll compile it and I'll use the LLVM intermediate language. And it's very difficult. LLVM's intermediate language and the whole tool chain is extremely hard to use. So I say that's sort of like level 3. Because you can do a lot of the basics of hooking up like learning how a compiler works with just, you know, some kind of lexer, some kind of parser, and GNU Lightning or some other thing that generates assembly language. There was like Asm C++, I think it was. There was another library that you basically kind of hand code the assembly language with C++, and it, you know, pretty much the same thing. And then there's also crafting interpreters, which is good, but I feel like he made a fatal flaw. So Bob Nystrom's top notch, right? Like, but if you go through crafting interpreters, you'll learn how to make one. However, downside is he starts off, the language is C, and then halfway through switches to Java, and I don't know why. It's completely pointless. Anyways, you can read this one for free. Yeah. So right here he switches to the JVM, and I don't know why. It's very weird. It's a strange decision. But anyways, yeah, the global context aspect of OpenGL was a terrible idea. Yeah, it is. Like, I get it, they wanted immediate mode, but it really wouldn't have been bad to pass it into each function. Yeah, it's just a little parameter, you know, to say what you're changing, you know. There's so many things to learn in doing so that can carry forward into using parser generators and VMs is not really. Yeah, I'd have to disagree with that. I think it's easier to write. It's kind of like Python, right? Okay, so if I go def my func print hi. So many programmers will say Python is so much easier to write. Yes, if you're already a programmer, this makes total sense because you're used to writing this. If you're a beginner, you haven't spent a lot of time writing this kind of code, then it's a little too difficult to kind of get it right. So beginners, when they do Python, they're constantly doing stuff like this. Def my other func. Because they just kind of don't get the indentation as a block, right? But if you do this, when you have bounding characters, they never make this mistake. They never do this, like ever. They go, oh no, that's wrong, right? Okay, so I think when you start off trying to hand code a parser, if you've never used a parser generator that forces you to write things with eBNF or BNF, then you kind of don't know how grammars like work, how they can be structured, and how you can like how to make an efficient lexer. That's what a lot of those parser generators do. So I always say use the tools first, make like a little toy language with them, and then try writing a RDP parser by hand. But also, every time someone writes a parser by hand, it always ends up being just like the biggest pile of dog shit, full of bugs, like so many bugs, man. If you ever wonder why like every web server for the last 30 years has been hacked repeatedly, it's because of hand-coded parsers. And I think the best way to put hand-coded parser versus parser generators will guarantee that it only handles the subset of the input that matches the language, right? Hand-coded parsers guarantee that it will only handle the subset of the language of the input that the programmer knew would come in, which means it doesn't handle all the possible inputs. That's the big difference. So you run into all sorts of edge cases where, you know, they just hand-coded the wrong thing, and then suddenly you can find an escape hatch and get through it. But for some reason, programmers love hand coding their shit. Hate tools. Okay, so these are all the things. VK buffer, VK image, VK pipeline, render path, frame buffer. So this is all stuff, like if you were doing your own game or whatever, right, from scratch, you would end up having to write all these things on top of OpenGL, right? Like in a way, like if you're done with a full-fledged, you know, you're working on RE engine or Unreal, you have these things, right? It's like Vulkan is basically giving you sort of like a design already, right? Would a protocol as simple as simple as HTTP 1.1? As simple. That tells me that you need to go write one. Go write one. I wrote a web server. HTTP 1.1 is not simple. That shit is nuts. Yeah, in my web server, I wrote I used a parser generator to parse it. And just by using a parser generator, my web server blocked like 80% of known hacks. Because all the hacks were basically what they would do is they'd find edge cases within the handwritten parser. I think another way to counter that idea, Bob, is like, if it's simple, then a parser generator should be able to do it easier than if you hand code it, right? So the idea that something is simple, therefore I will hand code it, kind of counterintuitive. It should be, if it's simple, well then I should be able to just, you know, generate it real quick. Okay, so this is all the stuff we got to work with. Engine initialization. First, everything is initialized. You create an instance. Okay, so you create an instance, and then on top of that, you add components to it. All right. And you create a pipeline. Okay, and then you have a render loop. All right. Okay. Project files and libraries. Okay. Okay, for the Vulkan engine, we use a specific layout. Assets, bin, shaders, chapter, third party. Okay, I have a slightly different setup, so we'll make the shaders. My stuff just goes in build, because I'm just using Mason to build it. Oh, let's confirm it still builds. Oh, and also, you know what I should do? Hold up. Just to make my life easier. Okay, and then let's just edit main. Then I should be able to do this. Yeah, there we go. From int to uint 32. Okay. Okay, let's just fix that so I'm not annoyed by it. Am I getting that backwards? Oh, to int. Sorry. I should just do it this way. Let's go like old school. Yeah, because I think SDL wants an int, but that's an unsigned. Okay, cool. We're in business. And then we can do, let's edit the make file. don't have any tests. Is it Hello VK or Hello Volk? Hello Volk. There we go. Okay, we can probably get rid of this. Should we keep the money command? Oh, that's the best. We don't need this one. We don't need Tracy. I should remove that from the other project. Okay, cool. Okay, I don't have any tests yet. Right, we'll look at adding those in. Okay, cool. So it doesn't do anything right now. It just kind of runs and then stops. Okay, we're set. Okay, and then oh, and also yeah. Actually, hold up. No, okay, yes. So let's copy. That's fine. I'm gonna get rid of the CMake thing. Should I? Yeah, I'll get rid of it for now. STB image, VK engine. Okay, git. Add dot. Git status. Okay, I don't have that online yet, but we'll see if we can get online. Okay, so we got some libraries. I grabbed all this already. Building the project. We got it working with Mason already. We got our third-party libraries. Okay, let's review this code. Yo, Unk, what's up? How much? I need to come up with the counter to Unk. What's the... You're a young dude. What do the young kids call each other? Okay, so code. We're going to look through the main first. Also, I realized what I'm going to call my my course on vibe coding, but I'm going to keep it a secret because I think you all will love it. Have to confirm it's not taken. Sammy, bruh. I think I need more hair for that. Nephew? Neff? What's up, Neff? Yeah, that's what we're gonna do. Yeah, Quest of Joy. Yo, Neff. That works. That works fantastic. Okay. Entry point for the code. This contains helpers to create Vulkan structures. This will contain image-related Vulkan headers. VK images. We don't have that yet, I think. This will create pipeline abstractions. This will contain descriptor set abstractions. This will contain GLFT loading logic. This entire code base will include this header. It'll probably be used by default. So this is all the types we need. Okay. Okay, first we initialize run. Sorry, with something. VK types holds this. My VK types do not have that. Hold on. VK types. My VK types is empty. And some defines. I wonder why it's different. Okay, let me just confirm that this will build if I do this. And we'll take a look. It looks like it's just like GLM stuff. Not GLM stuff. Libraries and things. Vulkan guy.h. Did I check out the wrong version of the code maybe? Because this is version 2 of the guide. Oh, I bet I have to get damn it, I bet I have to go get the yeah, I'm gonna bet you anything. Yeah, I bet there's going to be differences because for whatever reason this guy is using branches to determine to do the code. Oh, man. Quest of Joy. Man, ChatGPT told me Vulkan has lots of boilerplate since it's closer to metal. So I just reverted to SDL. Well, you know, if you're making just like a simple little game, you could just do SDL and some 2D stuff, man. You don't have to do Vulkan. I have a game that I did like absolutely zero OpenGL or Vulkan, and I didn't need it. But just doing something 2D, just stick to SDL and do it that way. And if you just want to make a game, don't do what I'm doing. I'm insane. I'm like trying to learn shit I don't really need. You can just go and like get any game engine. But if you really want to learn this stuff, yeah, you know, then you kind of have to suffer through the boilerplate. I suspect I got the wrong version of this code. I'm going to bet you anything I got the wrong version of this code. Okay. Surgery time. Surgery time. We have to get a branch. What is Vulkan? Vulkan is a graphics API, like programming interface. That's kind of like the new thing you're using to make, you know, any kind of 3D thing, games, stuff like that. Okay, we gotta go get this code. VK guide. GitHub. Okay. I have no idea why he did it this way. It's so weird. No server is available to handle my request. What? Game Boy emulator, Vulkan guide. Okay, cool. All right, Vulkan guide. What you have to do is you have to check out one of these branches. All chapters -2. I I bet you that's because this is like the version 2 of the guide, or starting point 2, one of the two. All right, we'll do all chapters 2. Get this code. Get clone chapters -2. Hey Smack, how you doing? Oh, we have a raid. I totally missed it. Thanks, Dev. Finally got a chance to raid you back. Well, you're welcome, man. Welcome to Uncatri's Vulkan. Yeah. That's the way to do it. Yeah, let me give you a shout out, Spagus. Yeah, so we're going through the Vulkan guide. Pinned it in the comment. And basically doing, seeing how it is. Everyone says it's terrible, so we'll see. I think OpenGL is pretty awful, so. But it looks like I started with the wrong, yeah, let's go all chapters. No, it's totally different. Okay, so it's not all chapters 2. It's kind of weird. Right, we just have to reverse engineer this guy's weird setup. No, I think he doesn't have anything there. Okay. So let's do... Did I already check out? VK guide, all chapters. Okay, we're looking for cat VK types. Yeah, super weird. Okay, so chapter 2. Yeah, at no point does he have that. I'm telling you folks, you gotta make your code run. It has to be runnable. Like whatever's in your course has to be exactly what's typed into your code. So how I do it is all my code in my courses is pulled from actual code that runs. I don't hand type the code into my books, right? Like it pulls it. So I know it's code that works, right? And it gets compiled and it's run. All right, so we gotta reverse engineer some shit. Okay, so first off, let's fix this stupid ass formatting. Okay, do that, do this, and then we're missing something. I believe this Vulkan VK enum string helper. I have no idea where that file is. We may just skip it for now, but let's see. That is not a file that exists. Alright, we'll get rid of that for now. We'll have to figure out how and why he's using that. Maybe it's a version difference? Okay, so that should give us... And then format, we're not going to use format. Yeah, here. We're not going to use format. Let's do format. Yeah, we're going to kind of upgrade his code, I think. I deleted something? Let me see. Yeah, probably. Hold on. Back up. That one's good. That one's good. That one's good. That one's good. This one's not good. And this one, not good. Okay, cool. Now we can read it. And this should be format, and this should be... you know, let's comment that out, because I think we'll need it later. Alright. Okay. GLM qualifier warning conversion to long unsigned int from int may change the sign. Okay. Where's this being called at? Okay, so that just looks like VLM, GLM stuff. Okay. Okay, cool. We'll have to deal with those errors. Okay, then make sure it runs. Make run. Okay, so we got his types. Let's take a look at what he's including. We have to find this. I'm not sure where that is, but otherwise it's Vulkan, VK memory, that thing, format, mat 4x4 and vec4 from GLM, and then this kind of VK check function. Yeah, I might actually redo that. Because we did in C++, we can kind of use my stuff. Alright. Oops. Vulkan will be very boilerplate terrible, but not heavy. Yeah, so this is kind of my thinking on this. Have any of you heard of a language called R? R, yeah. If you just go to Wikipedia, you can look up R programming language. Okay, so R is a language for statistics, right? And it basically forces you to write out how like the different statistics things go, right? So like let's say you want to do a linear model. You have to literally say the formula for the linear model, right? It's not hard, but you have to do more than like a package like SPSS, which is like you just go linear model and it just did it for you. In R, you had to actually know what linear model you were trying to do and how the formula would work, like how the X and the Y related to this or that, right? And you have to kind of build up everything. And when I was in college, I couldn't understand statistics. I mean, nobody really does. Statistics is just weird. But my professor, he was like, he was using SPSS only in the class. He used R. And I asked, hey, can I try R? And he's like, yeah, totally. Yeah, you should do R. And so because I was a programmer, because R gave you the building blocks of statistics and you kind of built it up yourself, I learned statistics from R. So I learned all the different various things that make statistics work, because you were literally like, you were building the formulas that made statistics work, right? So I'm kind of wondering if like Vulkan would be kind of the same thing. Yeah, you build up everything, but because you build up everything, you kind of learn how those things work, right? Whereas like OpenGL with like stuff that's just kind of happening magically in the background, you don't really kind of learn how they work, right? At the same time, if it's like a whole bunch of bullshit, then maybe not. R is a good example of a language that provided the industry with real improvements. Yeah, R is really cool. Abraxas, let's see. I forgot to tell you, after switching to Pop! OS, found out this version of the BIOS had its own hyperthreading and a bunch of other stuff turned on that didn't affect Windows, but was specifically for Mac and Linux if installed on the machine. Oh, interesting. Jansan, you didn't like R? Yeah, I think if you're a programmer, R makes way more sense. Oh, we got an advertising starting soon. Hopefully y'all get the good one. If not, well, actually, yeah, I'll take a break for about 3 minutes during the ad. And then we'll do this next part. We're just going through the code in the base thing. And the next is VK engine. And then we're going to start doing the next chapter of learning Vulkan. Yeah, this looks the same. Yeah, we'll confirm this is all the same. All right, I'll be right back after the 3-minute ad. I gotta go take a break myself. You hate your statistics courses? Yeah, statistics is weird. Yeah, especially I think programmers really can't grasp statistics. It's kind of the opposite of programming in a way. You've been vulcanized. Vulcanized rubber. Okay, so that looks good. What are we doing? Okay, we have our window size. We have a window pointer for SDL. Init, cleanup, draw, and run. Makes sense. Next one. Okay, VK engine. So far, this is already kind of satisfying the problem that I had with the OpenGL guide, is that the code was shit. So, like, it's tough to follow and understand code that's not organized the way you would normally write it, you know? Okay. SDL Vulkan, VK initializers, VK types, chrono and thread. Okay. All right, that'll probably come up later. Okay, init. Okay, so already the code is different. I don't know why. Oh, man, that's a big hit. These two codes have to match, man. Okay, I guess we'll just we'll upgrade it. Okay, and then reference. He's keeping a pointer around. And then here. Okay, so why the fuck is it formatting differently than that? I don't get it. I think I have a thing installed. I gotta remember what it is. Yeah, I think I know what that is. I have to go remove it. Is this defined in the file? Where's that defined? I think that's missing. Let's confirm. Ah, yeah, we gotta add that. Right about here. Alright, so it looks like we have to do a little bit of surgery as we go, but I suppose that's not bad. Okay, so it says the engine did that. Get that to match. Initialize equals true. Okay. Then we have a cleanup. And then loaded engine equals null pointer. And draw doesn't do anything yet. Okay, run. Okay. Let's compile this so far. Hey Lancaster, how you doing? Okay, it works, but we get those weird compilers from GLM. And doesn't do anything yet. Awesome. Okay, yeah, and there's more here. Okay, so if eType equals STL quit, if alright, we will be. I think I'll go get a tool that will fix this dumb shit. Alright, e.type equals STL window event. If e.window event equals STL window event dot minimized. Stop rendering. Okay, we need to figure out what that is. It's true. If e.window.event equals STL window event restored, stop rendering equals false. All event poll. We need one more there. Okay. So if stop rendering standard this thread sleep 4 standard chrono seconds 100. Continue. Alright. So if it's not rendering, it just kind of sits there sleeping for 100 milliseconds each, and then starts back up when you bring it back. Okay. That's the application main loop. Let's stop at STL receives STL quit, which we don't have access to because it's not actually running anything yet. So that's really irritating. I'm not sure why people allow warnings on their stuff. There's a way to disable it. I'm missing the stop rendering variable. Where is that variable? Should be like right here. Yeah, once again, if you write a book, don't type the code into your book. Pull it from your working code. Because this code doesn't compile. Okay. The cats? Yeah, Mountain Settler. Yeah, that's a great one. Alright, STL window event minimized and restored. STL. There we go. Okay, cool. It's running. Nice. Next part. And so far, nothing like crazy, right? Like it's pretty straightforward. All right, Vulkan initialization. The root of everything is the VK instance. This represents a Vulkan API context. You enable validation layers and anything you want. Once we create a VK instance, we can query it for what GPUs are available. Vulkan allows us to get a list of what GPUs are in a system and what their capabilities are. All of this information is represented on the device handle. Okay, a dedicated gaming PC, there will only be one. Okay, yeah, so you can reference different GPUs. Once we have a VK physical device of the GPU we're going to use, we can create a VK device from it. This is the actual GPU driver on the GPU hardware. Okay. And then you enable extensions on it. You can have multiple VK devices at once. And this is the way to use multiple GPUs from the same program. Okay, swap chain. Initializing the GPU is nice, but we want to actually perform some rendering into the screen. We use a swap chain for that. A swap chain is an OS windowing provided structure with some images we can draw to and then display on the screen. Swap chains are not in the core Vulkan spec because they're optional and often unique to different platforms. If you're going to use Vulkan for compute shader calculations or for offline rendering, you do not need to set up a swap chain. Right, okay. A swap chain is created on a given size, and when a resize, we recreate it. That exports the images. Swap chains hold a list of images and image views accessible by the operating system for display to the screen. You can create swap chains with more or less images, but generally you only want 2 or 3 images to perform 2 or 3 double. Okay, yeah. Full list of them and detailed explanation of Vulkan spec page here. Makes the swap chain not wait for anything and accept instant pushing of images. Result in tearing, generally not recommended. So I have a queue of images to present on refresh intervals. Often the queue is full of. As a full application will have to wait until the queue is popped by displaying the image. Strong VSync, okay. To the FPS of your screen. I always turn VSync on. I found like it, I always have to have it. I don't know. It seems to make everything run way better. FIFO mode, relaxed. Present mode, mailbox. This one has a list of images, and while one of them is being displayed by the screen, you will be continually rendering the other one. VK present mode, immediate. Is rarely used, only in extremely low latency scenarios. Okay. Either use mailbox or one of the 2 FIFOs. Okay, so you're creating a queue of images, you render to one and then you do the others. Okay. Initializing the core Vulkan structures. Okay, where does this go? Assume you start from the code of chapter 0. If you don't have the project set up, please grab the code. Okay. Okay, where does this go? What file? What file do you... Dude, tell me where to put this. Okay, alright. We're reverse engineering again. Alright, let me see. God damn it. Always say the file. Okay, this is vkengine.h. Where does this go? Okay, vkengine.h. I'm assuming here. VK initializers.h and the bootstrap library. VK bootstrap.h. All right. Initializers versus initializers. Failure. VK depth clamp mode has not been declared. Depth clamp range extension. Sigh. Okay, what am I missing? Let's Google this. There's probably an additional header to include. So we need that as well. I feel like that's not the right spot for this. The VK bootstrap layer via VK engine.cpp. Ugh, if it's in a paragraph, it doesn't exist. Okay, and then that fails because of the missing. Wait, what? Why am I getting that now? What the fuck? Why am I getting this all of a sudden? Okay, let's do that. Yeah. Okay, so this is an insurmountable problem. So why would I get that? Let's just do this. Shut that up, but keep it legit. Why would I need to do that? And also, why would you write? Oh, just shut up. Okay. VK depth mode extension. All right, let's see what else we can possibly do. Enable the extension. I think we have to define this. Let's see. Let's see how close the AI gets. Okay, so we don't need that there. Right here. Okay, let's see if that's the deal. No, it is not. Alright, somebody is about to get a punch in the face. This is really obnoxious. I think this is, Alright, we're gonna do a code search for that. Alright, let me see what we got. Remember, there's an option to this thing. Oh my god, dude. Just like... the issue is... this VK bootstrap is using an OR. And just assuming this is there, but it should be two separate things. VK depth mode clamp here. Depth mode clamp. Okay, so I remember this VK XML being mentioned in the config. I wonder if it generates some shit. And it's also only mentioned in this stupid VK Bootstrap project. So I wonder if I'm like using too new of a version. Alright. Well, we gotta build. We gotta learn how to build. This guy clean. Where are you at? This hot dog shit project. Not that one. VK Bootstrap, which seems to can't fucking figure itself out. God, I hate that, man. I really hate that. Like, build your shit on multiple platforms. And have some instructions. Alright, so we have to... There's two things. That project actually doesn't build because he's got some dumbass options. We have to do Mason... CMake object. And there was a weird-ass project I worked on a while back. Games. Where'd you go? Turns tar pit. I had to do this and this because of yet another stupid-ass project. libgit2 has all sorts of bizarre, like, hacks and stuff. So in here, yeah, this crap. Okay. Okay, we're going to put this here. CMake equals import CMake. So we have to get this project raw and then configure it to not use also okay, so we have to add defines to tell VK Bootstrap to not do that shit. There's like 2 things it needs. And then we do VK Bootstrap project equals cmake.subproject VK Bootstrap, but pass it the options. And then VK Boots dot dependency. Oh, actually, hold up. Okay, that creates the project, and then we should just go VK Bootstrap project. Okay, in theory, that should go. Then I just got to reset this, and I got to go look at subproject. On subprojects, yeah, here. There's Jankass. Okay, so here is where we set these defines. Okay, so we need to set, yeah, because it's trying to build the tests. And we'll disable this. By default, it builds all the tests for a library. I could possibly set that too. There was like an XML setting. No. Okay, so we need a way to turn that off. I wonder if it's downloading a different okay. Totally speaking your mind? Yeah. Okay, I gotta make sure I'm doing this part right. Okay. Okay, so I think that... Alright, let's see how that gets us. I think we need to redo it. Yeah, I need to re-download it. Alright, we'll do a reset. Okay. Oh, this is such hot garbage. Okay, let's do a full reset. All right, so there's something missing. I'm going to have to dig into VK Bootstrap to figure out, like, it looks like it's downloading its own version of the VK Physical Device Dynamic Rendering. Oh my God. They just enable a bunch of default features with no explanation about how to configure that. Yeah, look at all these errors. This is ridiculous. Installation is the most important thing when you write educational material. Making sure everybody's install is pure, clean, and very easy is your top number one priority. First whole chapter should be getting this to work. If I'm running into fucking errors like this, you done fucked up. It is so irritating. This is the kind of thing that when people come to learn to code or learn anything in programming, if they can't get this shit to work, the install, they just move on. And it's one of the simplest things to solve. You just show people step by step, install this, do this, do this. There's most likely some really simple thing I have to install or turn on or flip on to make this crap show up. And instead, I'm sitting here looking at Google output and typing in error messages. It's asinine. So then, who knows where the fuck this shit is? It's clearly like one missing header somewhere in this stupid thing. All right, so, and I don't even know where this is. Like, it's not in the code anywhere. It's not their code. Like, is it their own define? Oh my God. Let's see. No, it's just part of Vulkan. Oh. Awful, man. Just fucking awful. Alright, so we gotta go look at this stupid CMake file. Maybe there's a magic incantation in the fucking CMake file. Alright, let's try this. Also, we can tell it where the headers are supposed to be. So now it's supposed to download some stuff. We'll see what happens. Then I gotta figure out if it's downloading a different version than what I've got. No, none of that shit works. So far, this guide is fine. This, like, you know, you have to nail the install. It has to be top priority, every possible configuration you can think of. And you tell people, I don't do this on Ubuntu Linux because it's busted or something like that. All right, so we're missing some headers or some shit. Let's see if we can fake it out. Yeah, this is going so well. To have it just eat shit is just unbelievable. Over like a stupid install. And you could have specified it, man. I have to tell it where the Vulkan headers are, but I don't know if this is relative. Like, where is it relative to? Like, do I gotta give it an absolute path of some kind? Let's try that. Who knows? And I guess we gotta just keep doing resets. Did we get lucky? I doubt it. I doubt it. God fucking damn it. Let's do this. Let's cause an error to make sure that we're actually telling it where to find those headers. No. VK Bootstrap. I got no fucking idea how to set that then. Alright, so it's not that. And that type is not in any of the code. Like, I literally have the Vulkan. Oh my god, I swear to fucking god, man, this is so stupid. Here are the fucking headers. I have all of the headers right there. The only project, the only piece of code that even remotely mentions this stupid shit is VK Bootstrap, and they can't find their own thing. I have downloaded the library from Conos Group in 3 different ways, and this does not exist in this code. And I don't understand how you can have a define that is checking for an either or. Because if you go and you look in this, hey Onzi, take you later. Take care. So if we go and look in here, I got no fucking idea, man. I suspect that I just have a newer version of VK Bootstrap or an older version. Vulkant. Perfect. They should rename it the Vulkant. Oh my god. Let's look for this. Okay, so I have Vulkan headers 1.3. This is looking for version 1.4. Oh my god, man. Yeah, the first thing I would do to fix this is I would have a little project. It just checks defines and goes, wrong, you must have this one. Go get this exact file, right? This dude is just playing fast and loose and just being like, whatever, man, whatever version you got. Okay, so let's do this. Let's do apt search lib Vulkan dev. What version are you? 1.432. Okay, we're gonna get rid of. It's most likely there's just like different versions that I have versus what they want. Okay, we've disabled that. We're gonna get rid of our own Vulkan headers. This. Get rid of that. Alright. Because that's from a totally separate location. Alright, we're going to get rid of that. We shouldn't need Vulkan headers. We'll just use the ones that are in the OS. Assuming that comes with the OS. Okay. Now let's reset it. Hey, Infinite. I'm doing good. I'm just trying to get this tutorial to work, and I'm held up by just stupid install stuff that shouldn't exist. It's like, this should not be a problem. And the first person to say Docker gets banned. Hey, happy Nora. Janet, we got a raid. We're learning Vulkan, everybody. It's going swimmingly. Welcome to my stream, y'all. Let me give you a shout out. How was your stream, Janet? I saw you're doing multiple streaming. How's that going? Can you teach me how to use CMake? I tend to use Mason. You see me right here. I just use CMake projects. I didn't really bother learning it. But Vulkan is like almost there. It's just there's this one library that's referencing something that doesn't exist and no explanation as to why. But no, the CMake is terrible. You do batch files? It's kind of the same. Professional CMake? Oh yeah, I suppose that's kind of the thing. Okay, I think we're closer. Okay, it was a version skew between what I downloaded versus what I have. Well, let's just double check. No world to make target test. What are you talking about? I got rid of that. Ah, no, I didn't. Okay. All right, success. I'm telling everybody, the very first thing you do if you write any form of docs or educational material and technology, install and setup is the #1 killer. If you don't get people set up with a clean, ready to go install that works, they just move on. They don't learn the thing. They don't use your project. Nothing. Finally, Janet's on the phone right now, talking to the guy who's supposed to install the floor. Ah, nice. Okay. Awesome. Main joke. The name is no joke, though. It will teach you what it means to be a professional with CMake. I believe it. Yeah, I believe it. I mean, it's just CMake is incredibly weirdly done. I mean, it's so bad that they had to get a grant of $4 million to fix it. That's not a good sign. Hey, whoa, we got a window. We have a window. Everybody, you have to bow down to the glorious code. We have a window. Let's see, how long? 2 hours to get a window. Yay. This is going great. Sergeant Pepper. I'm glad you stopped by. You can laugh at my skills. How's your Rust Godot thing going, man? Okay. Okay, everything is there. It's working. Don't breathe too hard on it, though, because it might fall over. All right, back to the Vulkan guide. Although, so far, I will say, like, yeah. I got issues, but that's just because this is sort of my job is writing documentation that people can follow. So, but I will say, so far, the Vulkan guide is far better than learnopengl.com. Okay, now we can go into vkengine.cpp. All right, Vulkan engine. Okay, first thing we need to do to initialize is the Vulkan instance. For that, let's start by adding a new function that stored handles to the Vulkan class. Okay. We need to go to the header file. It's omitting some stuff. Whereabouts is he putting that? All right, we're just gonna fix this up real quick. Okay, VK instance. So that's your core instance. Okay, VK debug utils messenger extension debug messenger VK physical device. So you make a physical device. GPU. I kind of want to get like that second GPU I was thinking about getting. And then run this code on there. And then we need a device that comes with the GPU. And then we need a surface to render on. KHR. Surface. Okay. Let's confirm this always works. Which CPP? This one I am doing 23. What are you? What are you? Why is Ubuntu in my face over that? Hold on. Oh, I can't get the working directory. Hold up. I deleted stuff. Learn Vulkan chapter 0. Is that right? Yeah. Okay. Actually, I'll just go down here so y'all can see the code. And then, blah, 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 blah. And then build. That's what we got to do. Sergeant Pepper, it's going slowly but surely, but just got my TCP socket protocol worked out recently. Nice, okay. Yeah, because your game's it's not PvP, but it's like multiplayer. Ah, damn it. It's kind of weird because like normally I code in Windows, and my setup in Windows is almost exactly the same. Like if I flip over, it's like nearly the same. That's Windows, that's Linux. And it's strange though, because if I go to Linux, it takes me a bit to kind of get in the flow. It feels like my hands are muddy, right? While I'm working on it. Okay, those warning messages are crazy annoying, but that's fine. I'll be able to disable that. Okay, so now we have to do some private methods. We'll go with it. I normally don't do private, but... Alright, init swap chain. Void init commands. Void init sync structures. Alright, that's what we're doing. Let me see. Right now, we need those functions kind of laid out. Let's add them here as well. Void. What's this thing called? Vulkan engine. Void Vulkan engine. Colon, that. What do we need? 4 of them? 3 paste. Let's see. Init Vulkan. Init swap chain. Init commands. Init sync structures. All right. Success. Confirm it runs. It runs. Okay. We will now call those init functions in order from our engine init function. Okay, so we go to the engine init function here. And then initialize it there. So we go init Vulkan, init swap chain, init commands, init sync structures. All right, so far so good, but we also haven't really dipped into the actual way you do Vulkan stuff. Cool, all right. Init Vulkan, yay! Our first real Vulkan code. Yay, yeah. Okay, so VKB, that is the Vulkan boilerplate thing. And it has a builder interface. All right. Make the Vulkan instance with basic debug features. Auto inst ret equals builder dot set app name example Vulkan application. All right. Did I type that correctly? I did. Okay, so then request validation layers. Boolean use validation layers. Did I make that variable? That variable does not exist somewhere. Is it here? It's not there. Did he mention it anywhere? Yes, it's up at the top. Okay. Up here. Oh, no, it's right there. I just probably typed the name wrong. Okay, whatever. We're down here. Builder. There we go. Okay, request validation layers. Use the default debug messenger. Require API version. Okay, now we find out what version he's using versus what we're using. This is gonna fail. I'm pretty sure that'll fail. VKB instance VKB inst equals inst ret value. Grab the instance equals VKB inst.instance and debug messenger equal VKB inst debug messenger. All right, here we go. Let's see, Lancaster. He said, what do you think? Oh, I want to thank you for being a good boost for productivity. Oh, awesome. Yeah. I'm telling you, man, you all are a good boost to my productivity, so I come in here and actually do work. All right. We need a builder, not a boulder. And you're welcome, Lancaster. All right. That's apparently a success. No idea what it'll do. I don't think it does anything. Yeah, it just does that. All right, no failures that I could detect. Let's see. For the creation of the instance, we want to have the name example bullet Vulkan. You know, all that code is really easy to understand. Also, I'm surprised that actually worked. We also require API version 1.3. I'm going to change it to 4, and then if this is a problem, I'll adjust it down as appropriate. Let's give ourselves a raise. Have I shown you my make money command? I don't know if I have it installed. Let me just see. Yeah, I don't have it here. It's kind of a running gag in my other game I work on. Okay, yeah, that all makes sense. I might go back and read it, but okay. Then we initialize Vulkan. Wait, we were just doing init Vulkan. And just grab the valve, otherwise it would leak. Wait, what? Why is this init Vulkan different? Okay, we gotta read. This is what catches the log messages and validation layers. Let me just adjust. Okay, so what is this one? To select a GPU to use, we use VK device selector. HR object from the SDL window. Oh, okay. So that was version 1, I guess. Oh, okay. He's slowly building this up. Okay, so SDL Vulkan create surface window. Wait, what? Instance. No, this would have to come after. Hold up. Oh, okay, so this is more code. Dude ran out of space in the book. He's like, okay, we'll just cut this in half. I should just use Mason. I don't know. I mean, Mason could be way more awesome than it is, but it's a lot easier to use than CMake. Especially when you want to grab dependencies. That's when it really does a lot better than CMake. Okay, so right here we do SDL Vulkan create surface. All right, everybody, we got an advertising starting soon. We have to help Daddy Bezos pay for more plastic surgery. He's got to get those, that synthol in his muscles. So everyone be sure to watch the ad. Don't, whatever you do, find anything that blocks ads. That's illegal. You can't do that. And all right, we'll add some of these. All right, we'll stop there for the ad break. And please think of the billionaires. You have to make sure that they get more yachts and stuff. So enjoy your advertising about casinos, because we all know that's probably what you're going to see. Casinos or anything related to casinos, gotcha games, stuff like that. All right, I got some tea going. So let me show you the game I actually work on. A little C++ game I got. We gotta switch over to Windows real quick. Let's set a timer for my tea. It does build on Linux, but I've been working on it in Windows for a bit, and it's probably a bit rough at this point. Here we go. All right, everybody. So in my free time, so my main gig is I teach people how to code. LearnCodeTheHardWay.com. I have a whole bunch of courses I do for programming. Latest course is a Go course. You can read it for free. Here, if you want to learn Go programming, here you go. Today was women's underwear ads. Not bad. Very necessary item. Much better than casinos. All right. And for fun, I started getting into game development this year. So started making a game. And think of it as what I remember of games from the 80s. So it's not totally accurate, but that's kind of an impression of it, right? And I do all the art myself. And then I run it through a Go program I wrote. This is all C++ code. It's all hand-coded by me. It's actually all 2D, but I'm faking it. And then I run it through this program that pixelates everything. Kind of makes it all janky. We'll go with a fire weapon. And then you set everything on fire. It does have sound, but the sound's super annoying. So I disable it while I'm working on it. It's all turn-based. You can think of it as kind of like 3D Rogue. Like that. And so the general idea is you go through, as you kill enemies, you pick up their stuff, and then you make more and more advanced weapons. So now we have this weapon. And your weapons are just like magic spells. And what you're looking for is there's an exit. If I can't find it, I'll use my debug key. Everything's randomly generated. Oh. And we can heal, we can pick up items, like everything's there. Okay, so I can't find the exit. Yeah, so I can pick this up, and I can use it. Okay, so assuming you find the exit, you then get a cutscene. No more up in jail? No, we'll be back to it in a second. I'm just showing people. They asked about my game, so. I'll show you the cutscene, because it's so bad it's good. But anyways, so this is actually just a comic book panel, and then what I do is I move a camera through it, and I do it based on an audio file. And then the boss fights are going to be turn-based boss fights, kind of like in old games like Chrono Trigger or Final Fantasy. So you pick your action, then you get hit. And then that's a mistake. So it should be focusing on the boss. The boss got hit. And you get hit. But I got to work on this part, panning in and out. It doesn't work right. And then when you're done fighting the boss, assuming you win, you go back to crawling the dungeon, finding items, solving puzzles, that kind of thing. Alright, so that's the base of it. And then the really terrible cutscene story thing. It's a prototype. You like the art? Thanks. Okay, we gotta pause the music. Enter the final stage of the dungeon. Oh, so bad. You open the door, and before you, you see a horrifying... Prepare to cringe. I'm just gonna warn you. Sight. Something that nobody has seen before. That everybody is afraid of. I get so embarrassed every time I play this. Rat. Hey, kid. Okay, I'll just leave that in. Fuck it. We're going for it. He turns to you. And he says, in his voice, okay, so that's the cutscenes. Hopefully they'll be either similar or better. We'll see. I don't know. That was just a quick. When you get called up for Hollywood, thank you, thank you, thank you. I will remember you little people when I am a famous voice actor at Disney. It was a quick and dirty one, right? But let me show you how I do it, because yeah, it's great, but also every time I play it, I'm like, so let me show you how I make it, though, because it's actually kind of interesting. All right, so here's what I do. And like as far as like a game development thing, let me look up Acid Stories. Okay, so a story is defined as like a background that I'm playing, right? So that whole thing, all those little panels, it's actually one giant image. And I just pan between them, right? And then I have an audio. So this is like that audio you heard. And then on the panel, there's like a layout. So I can define like, here's the whole thing. I can say, here's panel 1, here's panel 2, here's panel 3, here's panel 4. And it'll pan, the camera will go here, shake, pan here, shake, pan down there, dolly up, come in, zoom in, out, show this whole thing, pan down there. And then I have time codes. So at this time code of the music, so I have the music, right? And the voiceover. Then at 6, it goes to A and it does a pan. At 13, it goes to B and does a pan. Here it goes, just immediately jumps to H and then does a bounce. And then this, remember when the Rat King went, right? Okay, so that's what it did. It just jumped to that and then did a shake. So I have all these like camera operations, right? And the cameras are all defined in assets, cameras. So I can actually kind of just define different cameras. I can say this one moves with this kind of easing and this kind of motion, moves this quick, has a minimum and maximum. So I can define like different kinds of motion really easily, right? Okay, so that's the base of it. But how I get that data is I use Reaper as a video and audio editor. And what I do is I find where the audio is, what I want to do, and I put a mark. You know, like if you've ever used a DAW, this is what would go in a WAV file. So it's a WAV file marker. And it just says B, where I want to go, and then pan. But notice it's kind of got this odd syntax, right? Okay. So then I do that, I kind of track it, you know? Rat. See? Okay, I'll just leave that in. Turns to you. He turns to you. He turns to you. So see how that says E shake? So it goes there and it shakes. And I kind of like, I'll do a round where I'll kind of guess and then I'll play it and then I'll run the video and then I'll actually like match it up, right? And so then what I do is I come up here, I go actions, and I have an action I wrote called storyboard timecode. Run that, and boom. I have my JSON that I need, so I copy that, grab it, go back over to that JSON file, paste it in, and boom, I have how the camera should move based on the audio. So it basically syncs the camera to the audio from my DAW. And there you go. So that's how I do my storyboards. Now, so the next thing I'm working on is the boss fight. I have to actually... I never really played a lot of turn-based games, so I might have to go grab something. I have Chrono Trigger, that, or maybe just play Clair Obscur or something. And there we go. That's my game. Okay, so now, back to learning Vulkan. Alright, this is our next jam. Interesting workflow? Yeah. I kind of have to figure this stuff out on my own, so I don't know if that's like what anybody else does, but it's sort of like, I don't know, it's kind of the advantage of writing your own code is you can just sort of figure out optimal workflows based on tools you have. Downside is you have to figure out optimal workflows based on tools you have. So it's a double-edged sword. Need to get at this variable. Yeah, okay, here we go. Alright, life is too short to type this out. I know what that's doing. I'm going to copy pasta that. Also, I feel like we need to change up the music, so give me a second. Right. It's asking for 1.3 features. I don't know. All right. Am I using AI? No, not at all. But I might start a project where I try to do it entirely with AI. Because I suspect I could figure out how to kind of do it, but also kind of make it very solid. Effectively turning it into a code review process. All right, everybody, we're gonna kind of up the energy in the music. This is far too sleepy for rage coding a Vulkan engine. We're gonna go for lo-fi house music. You've been using Grok for code? Is it embedded in your editor, or you just go to Twitter and ask it? Drum and bass. Yeah, it's pretty similar. Okay. Use VK bootstrap to select a GPU. Say we want a GPU that can write to the SDL surface. Okay. VKB device selector VKB instance. Okay, we get a physical device. Okay, we have a selector. Set minimum version. I feel like that minimum version has to match. Let's make sure that goes back. And then 1.3 features. Set required features 1.2. Interesting. I mean, already this is way better than OpenGL. Like having to go to a website and have it generate me a header file full of defines just to figure out what functions I have. God, that's terrible. Selector was declared. Missing initializer member. Shader output layer. Shader output viewport index. Oh no. Great. This is awesome. Oh god. Alright, so looks like there's like more code in the VK bootstrap. Let's see if we can just remove that and get somewhere. These are just warnings, which is annoying. Alright, that's the actual error. Selector. What do we think of Claude AI? I haven't used it, but there might be other people who do. Copilot's in your editor. I have Google Pro, so I don't want to pay $200 for Grok Pro. Okay, nice. Yeah, I haven't really done any AI stuff. I tend to be like, I don't know, the opposite of AI. I don't even use LSPs or any tools. I just do, yeah, straight Vim and code. All right, wrong index for variant. Bad variant access. Terminate called after this wrong an instance of standard bad variant access. Interesting, okay. Let's bring back these features and then let's fix this error. Your editor to Google Pro? Is that like a code editor, or is that something else they came out with? Okay, so. Okay, that's bombing. Interesting. I wonder if it's because we're using 1.4. You know, let's go 1.4. Minimum version 1.4, and we'll just kind of assume we can do this. And we'll just try to add just continue the trend. Let's do 1.3 and 1.4. Four, 1.3. Now, assuming that doesn't get us into trouble later. Also, it could be that we haven't set everything up correctly, so it crashes because of that. So let's continue the function and then features 1.4. 1.4, 1.3, 1.3. Okay, cool. All right, so we should have it configured for 1.4 or 1.3. It's a Visual Studio pattern. Oh, Visual Studio extension. I see. Iron Hook, had you used Doom Emacs? Yeah, some people have said that's actually a good version of Emacs. Good setup for it. Okay, so we're getting some crashing, but I think we're not done setting things up. And that failed. Why you fail? What is your problem now? All right, the warnings are nuts. No, that's just a warning. Oh, interesting. It doesn't have... Okay, let's undo that. Let's just undo that. Yeah. Let's just go 1.3 then. Yeah. Okay, let's stick to that. I don't think that's the issue. Okay. Yeah, it's probably crashing because we're not done setting it up. Okay. In theory, let's hope so. Okay, and then that selects the GPU. That gives us a value of a physical device, and then we do VKB device builder, VKB device equals device builder dot build value. Oh, right, because you have to pass the physical device to this virtual device to get an actual device. Okay, and then the device we finally get is VKB device.device. I'm kind of curious. I bet this Vulkan bootstrap or boilerplate thing is probably hiding a ton of code. Alright, chosen GPU, physical device. Okay. Let's see what we get. Let's see, Noah, what's good about Vulkan? I just know it's used in GTA. Well, it's supposed to be a cross-platform graphics engine that is more control over what you do. So you can control every aspect of how a GPU uses it. And also, from what I see, use a GPU for non-graphics things, which I think is really kind of its actual probably key point, right? Because you can load Vulkan and you can do no rendering to a graphics context, just do all compute shaders, which is what you need for Bitcoin mining, AI, things like that, right? So I think that's its actual main use. Cannot be used as a function. Oh, it's a device. Okay, there we go. Those warnings are nuts. I have to find out why why there's so many. Okay, let's see if this crashes still. Yeah, it does. Wrong index for variant. Super cool. Let's see what we got. Uh, 41. And a net Vulkan. And 138. Here, huh? And what's the error message? Wrong index for variant. Wrong index for variant. Oh, this API is using the variant stuff. Where are they doing it? Physical device error. I wonder if we're using too new of a compiler. Let's just double check. Physical devices selector, minimum features. Ah, we didn't set a surface. There we go. Set surface. Set minimum, set required features, set the surface, select value. VKB device builder there. VKB device builder build value. Device. Okay, there we go. Why did they make Vulkan so complicated? Yeah, it's just to give it like tons of configurability. But so I was going through the OpenGL stuff. And OpenGL is a lot of sort of like hand-wavy magic behind the scenes. So I'm kind of wondering if like I will actually find Vulkan maybe more understandable because it's kind of a modern API. For example, in order to create a physical device, I have to pass it a VKB instance, and to make a device from that, I have to pass it a physical device handle, right? Whereas in OpenGL, you just go make the thing and it just kind of magically figures it out, right? So for me, that structure makes more sense. Whereas like when I was going through OpenGL, it's like, oh, I make a buffer. Okay, well, how do I connect that buffer to my vertices? Just do stuff. No, dude, like I need to pass the buffer in, right? Like, no, you just do it behind the scenes and that's it. Okay, conversion from physical device selected to non. Where is surface? Create surface. Okay, so I must have given surface the wrong type. Conversion from VKB. Set surface. Okay, yeah, so that variable must have the wrong type. Surface. Conversion from VKB, physical device selector, to non-scalar type. What the fuck are you talking about? Oh my god, man. The builder interface is killing me. How would... That's the wrong... That's such a messed up error message. That should be like a very different error message. Yeah, but then it just pretended as if I was going to town on the result. That's just weird. All right, anyways. That means I didn't even get the value. Like, wait. No, I must have done something else. Okay, it doesn't crash anymore. Yay! I am a real programmer. All right. Okay, and then chosen GPU. Nice. Okay, so now we have a GPU selected. I wonder if we could print out that info. That'd be kind of interesting. Should we try to push that and go for 1.4? Let's do 1.4. All right, let's do features 1.3. Or should I just like don't poke the bear? Nah, let's not poke the bear. Let's leave the bear alone. We'll try and see if I can get to use 1.4 later. Okay, so the next thing is initialize the swap chain. Okay, he's doing some other code thing. Okay. Oh, so this was all of that. This here was just to support that one function. That's crazy. Okay, all right. So next. So this is, let's do this. Device selection. This is swap chain. Okay, VK swap chain, KHR. Swap chain. VK format. Swap chain image format. Okay, standard vector VK image, swap chain images, standard vector VK image view, swap chain views. Okay, so you need a vector of the images you're going to work with and the way that they're being viewed, and VK extent 2D, swap chain extent. I need a format and swap chain. So that's how you actually display to the screen. Okay, and then in our private section. Oh, wait, you're on Ubuntu now? Yeah, I flip back and forth. I use them both all the time. And I have a Linux OS 10 box over there, but I need to reinstate it. It got banned after I had to move it to the other side of my desk. Okay, and then here, so this is void create swap chain uint32 type width, uint32 type height, void destroy swap chain. Okay, alright. And then let's go here. And then this one is destroy swap chain. Okay. Yeah. Going to be discontinued unless NVIDIA and AMD get discontinued? Well, if you listen to some people who talk about the stock market, that's very possible. Very, very possible. Okay, VK format does not swap chain. Wait. Capital V. VK format. There we go. These companies are government backed. They're too big to fail. Well, they're tech companies. Too big to fail only applies to banks, because the banks basically own the government. Extent 2D. Extent 2D. Hey, Sophini. How you doing? You can write good AI code with one person, but when a million people use AI to write code, submit the code, it'll make it a lot better. Oh, you're talking like as people write code, then they improve the training. You know, in some ways, I think that's kind of one of the business models you're going to see. They make it free, but they basically, you know, you remember, if you don't pay for something, you're the product. VK extent to capital D. Did I run it? Alright, so the warnings are really irritating about missing initializers. I would like to go see what that dude is doing in his thing. I think he's playing fast and loose with default initialization. No declaration matches create swap chain. Okay, cool. What is it called? Oh yeah, it's lowercase s. Riven main. Would you say that after I finish your course, I would be ready to say I'm confident in JS? I'd say after you finish the course, sit down and do some replicas of a ton of web UIs, or go make like a bunch of little tools. And I can actually show you like a good example of that. So in my website, I have this commands directory, and these are all just like little things I needed. This one generates my books. This one converts videos. This one deploys my stuff. This one does some templates. This one sends my emails, just generates, it was an old one that generated video players. I don't need that anymore. This makes thumbnails. This runs a tracker. This was a quick one I did, one-off, that just converted my old Python 3 book to the Python 2 format, you know? So do this, just make a whole bunch of these little tools. And if you don't have any ideas, then look for GNU Core Utils. So look for this project, GNU Core Utils. Google that, go to the online manual, right? Go to HTML with 1 page per node. Don't do the big one. It's too hard to use. And then all you do is just kind of start at the top and pick like concatenate and write files, cat. And then make a tool that replicates this. This is like a standard Linux tool, right? And then go and try NL, line numbers. So if you did a whole bunch of these, you would learn tons and tons about how JavaScript works, how to make projects. And you want to keep your projects small. Super small projects are better than big ones, because probably the number one thing to kind of learn as a beginner is how to get started and how to finish. Stuff in the middle is important, but getting started and how to finish, if you just practice those two things, then if you think about it, big projects are just a bunch of little projects. So you can accomplish big things by just cutting it into small things and then start, finish until you get done. So if you went through this and you did like, say, I mean, there's a lot of tools in here. If you did all of these, you'd be a grandmaster of JavaScript on the back end, which would be totally useless. Let's be honest, like nobody's asking for that these days. But you would learn a lot about how systems work, how systems programming works, how files work. Like these are all like really important things to know. But I would do like, I don't know, 20 or 30 of these and you'd be set. Then switch over to doing finding websites that have interesting JavaScript front ends and kind of doing them with JavaScript, and making copies is your biggest one, and then start working on your own ideas too. I jump on these after the course directly. I mean, you could try them out now. Like you can, it's always good to kind of like try to see how you're doing by like, just sort of like, you know, like let's say you get halfway through and then be like, hey, let's try to do cat. And just push yourself to see like, can I figure out how cat works? And if not, that's fine because you're not done yet. But yeah. And it's a lot of looking stuff up. Don't be afraid of or ashamed of having to look things up. I look things up all the time. So you just kind of look up, how do I do this? How do I do this? And slowly you learn how to do it. And then the other thing I would say is I find people are more capable if they know multiple languages. So do all that stuff in JavaScript, make a couple little like web front ends in JavaScript, and then go learn another language. I recommend Go because I have a Go course, but I think Go and JavaScript go together like peanut butter and a bit of chocolate with hair in it. That's the JavaScript side. So yeah, just go learn Go. And then after that, I don't know, learn C, learn C++, learn anything else you feel like learning, Lisp, Haskell, anything. Because generally I find when people know about 4 languages, they're super capable. They can learn any language, they use almost anything they run into, and they can make almost anything that they want. But if they only know one language, they tend to be stuck in like one way to do things. It's more difficult for them to think of new things to do, you know? So yeah, try to hit 4 languages. And after that, I think you're set. Recently I overdid it. I tried building a PDF reader, currently in the related rabbit hole called Huffman and Deflate coding. I mean, that's a hardcore project. That would be a very, God, that's murder. A PDF reader. Oh man, because you have to implement kind of a postscript, right? Which is basically a fourth. Have you ever done any fourth programming, Blowfish? A fourth is very easy to implement. You got this ebook off Humble Bundle? Yeah. Yeah, I wrote the hard way. I missed your question. Oh, but Riven, to answer your question a little more directly, I would say I would be ready to say I'm confident in JavaScript. I would say no. A key thing of my courses is I teach you all the stuff you need to know to then go learn JavaScript or learn something, right? So at that point, you have all the basic core skills, so that way you can understand the more advanced topics that you'd find with other courses or other places. So I'd say you're not really confident yet, but you have everything you need to become confident. That's the idea, right? Even a little bit of fourth? Oh, Scott, I was confusing you with Blowfish. Yeah, fourth is interesting. It's incredibly tiny. I think far superior to Lisp as far as like a small embedded language, but at the same time, it's definitely a write-only language. You pretty much write it once and you're done. Okay. Now we're creating the swap chains. Swap chain time. Let me see. Create a swap chain. Here we go. Fourth really help you with understanding is a stack. Yes. Yeah. And also just like, if you ever struggle with recursion or converting recursive algorithms to not recursive algorithms, languages like fourth are pretty much the kings of that. Because every time you do a recursive algorithm and you convert it, you effectively have to recreate the stack and all the stack operations. So it's kind of like a good training ground for that. Okay, so we're gonna make a swap chain builder. Chosen GPU, device, and surface. Oh, did I call these in the main? Hold up. I'm not even calling these. Holy crap. Oh no, I am. Yeah, because it's in the init. Okay, cool. I just confirmed that. Init. Yes. Init swap chain commands. Got it. Perfect. Okay. Swap chain image format is Vulkan format B8G8. So RBG888. Interesting. Let's just copy paste that so we don't make any mistakes. Okay, cool. And then let's do VKB swap chain, VKB swap chain equals swap chain builder. Okay, he's commented this out. Use default format selection dot set desired format. A VK surface format, Chronos group format equals okay, use vsync present mode, set desired present mode, VK present mode, FIFO KHR, set desired extent to width height, add image usage flags, VK image usage transfer DST bit and build and then value. Okay, make sure I didn't make that stupid mistake. No semicolons. Okay, great. Let's compile that and get it to work. failure. Alright, where we fail. Oh, unused variables. Yeah, whatever. We'll use that next. Okay. Swap chain extent equals VKB swap chain dot extent. Swap chain equals VKB swap chain dot swap chain. Right, that's a lowercase c. Surprised it's just going into a straight vector. You would think it would be like a hard-coded array with like a single size. Okay. Swap chain. Oh, I must be missing a variable. Oh, swap chain image views. There we go. Optional underneath, I believe, yeah, it was a variant, I think. Because I did get an error from the variant being wrong. Also, I'm not sure why it's not. That's me being dumb. I would almost rather have these in like little structures on their own. Swap chain image format. Yep, because I spelled it with 2 P's. Okay, we have success there. All right, next up, story swap chain. Huh. All right. Let's confirm it. Kind of runs. Learn Vulkan Chapter 0. Make run. Alright. No crashes. Doesn't do anything yet though, but is to be expected. Okay. And then init swap chain. Oh yeah, we just call not that. We go here, create swap chain window extent dot width window extent dot height. Okay, was that a success? Let me see. Yeah, okay, great. Okay, then cleaning up resources, cleanup. We have to add to that cleanup. That's kind of different. Okay. destroy surface khr instance vk destroy device vkb destroy debug utils messenger instance. See, this all makes sense to me. Yeah, you pass the instance to everything. The first thing is the instance. It's basically an object-oriented API. Oh, and then we destroy the window. Okay, let's try that. A VK guide, this book is definitely better than Learn OpenGL. So far, everything has been, the only thing was a small hitch up with the setup in the beginning. And also versions of stuff, you know, just the classic thing that always happens with these courses. But as far as the way things, one, the code is better structured, far better structured. So everything has a small concept. It's maintained in, it's using C++, actually using C++ instead of some dude's half-assed C and C++ thing. Everything is in like, here we go. How do you destroy a swap chain? Boom. How do you initialize a swap chain? Boom. How do you do this? Yeah. And then the way he explains like the steps, like first there's a lead up. You're going to do this, 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 and this. All of the code runs. You get started with some simple code to start. Like so far, everything is like way better than the Learn OpenGL. As far as Vulkan versus OpenGL, I'm going to make the bold statement that I think it's wrong to tell modern programmers to learn OpenGL first. OpenGL is very much sort of like a jank-ass, old-school API that doesn't follow, like it's pre-object-oriented programming. It's like really weird. Whereas like Vulkan, yeah, I'm typing a lot of crap to get it to work, but everything makes sense, right? It like, you have an instance, and then you create devices, and then you create surfaces, and like everything has got a logical structure. Parameters seem to be in the same place. It's more consistent. It's not like, oh, well, in this one you bind a buffer, but in that one you attach a vertex array with a separate thing, but then you build the vertex array. It's like, it's not all over the place so far. So I'd say so far as like, if I had started with learning Vulkan first and then tried to learn OpenGL, I think I would have the same opinion, right? I'd be like, wow, OpenGL is just dog shit. It's all over the place. This is so weird. And Vulkan so far is like, oh, I make a device, and then I hand the device to the thing, and then I make a swap chain, and I put the swap chain there, right? Now, the caveat on this is this course is very heavily using this Vulkan boilerplate or bootstrap thing. So I imagine behind the scenes of this, it's probably some monstrosity code, right? I think if you had to do Vulkan raw, it would probably be way worse. But Vulkan with the bootstrap, so far, I don't know. Yeah, you just make the objects and put them in the right spot, and then you're done. All right, so we'll see how it goes once you put it further, push it further. We're now destroying the instance before the device and the surface. Oh, okay, so you want to see a validation error. Okay, so let's run it. And then when we exit, cool. But now let's do, he's showing how to do an error. Go into cleanup. Actually, when did, I don't have destroy swap chain actually. All right, let's confirm that actually works, and then we'll test the error condition. Is Vulkan good for large games? I sort of have a theory that one of the reasons why games over the last like 4 or 5 years have started to suck is because Vulkan is too hard to use for like a game. I think it like nerd snipes game developers. So they get obsessed with like pixel perfect accuracy crap, and then it just makes it too difficult to actually make the game. Okay, so now to replicate his error, we're going to destroy instance before. Okay, we're going to move destroy instance before, and then we're going to see an error. But I would say, yeah. I imagine someone who's like a better graphics developer than me would probably be able to do way more amazing things with Vulkan. I'm pretty much going to get like a cube to run or something like that. Okay, yeah. So then you get VK, destroy, swap, change, and valid device. Nice, okay. I like me some errors. I use Unreal Engine 5. Monster. Yeah, it's supposed to be very good, but I think everyone went to Unreal Engine 5 but didn't update their art process. So I think that ends up being a big problem for the games that use it. Because the way you have to do the art for Unreal Engine is completely different. Like you don't do LODs or anything like that. You don't do you just make your models many triangles as you want. That's the claim. But I think people go in there and they like reduce the triangles like they used to, or they make their art the way they used to, and then that causes problems for Unreal Engine. I've also heard the other problem with Unreal Engine is it's not good for level streaming. So doing like large open world games is kind of its weakness. But we'll see, because they're using it in The Witcher 4, and Witcher 4 they're not going to put up with that. I mean, CD Projekt Red knows what they're doing, so I think they're going to whip Unreal Engine into shape when it comes to that. In fact, what I've heard is Epic just sent a team of people and they just work for free for CD Projekt Red just to make it work for Witcher 4 in order to get it to work for open world games, and like that's like a big thing they know is probably a weakness. All right, executing Vulkan commands. Vulkan command pool. All right, so you make a pool, you allocate it, and into the buffer. You do your render pass, your draw, descriptor sets, command dispatch. We might be reaching the limits of my brain power on this one. Let's see. Unlike OpenGL or DirectX pre-11, in Vulkan, all GPU commands have to go through a command buffer executed through a queue. The general flow to execute the commands is you allocate a command buffer, you record commands into the buffer, you submit the command to the queue. Okay, it's kind of a client server. So it's HTTP, but for GPUs. VK queues are in Vulkan execution port for GPUs. Every GPU has multiple queues available. All queues in Vulkan come from a queue family. The command pool, command buffer. Okay, all right. We will begin by writing our frame data structure on the VK engine header. Okay. Okay, we also need to add those into the Vulkan engine class alongside the members we use to store the queue. Okay. Yeah, okay, so kind of like just a cheap ring buffer there. Check out Threat Interactive on YouTube. Oh yeah, he talks about how a lot of those games kind of mess things up. He's also a notorious pixel peeper. One of those guys who pauses the game at the worst moment, zooms in to where nobody will see it. It's like, this is terrible, and it's like a little bit of ghosting. Okay, so we get the current frame. We have a graphics queue. Okay, and let's do... Actually, this should probably come up here. Let's do frames, command buffer, and then let's go here. It's initialized internal data. Let's call it that for now. Okay. We now need to find a valid queue family. Okay, it might not be accessing frames to array directly. So we add a getter. Okay, good. Now we need to find a valid queue family, create a queue from it. So we want to create a queue that can execute all types of commands so that we can use it on everything for the engine. Allows us to get the queue and family directly. Okay, so we're going to go to init Vulkan. Noah Raptor, I want to be an expert in C++ again. Oh, did you used to do C++? It's changed a whole lot. When did you last use it? And Nish, do you have any project plans for Vulkan already? Oh no, I'm just dorking around. I mean, maybe I'll try to use it on another game. I'm having too much fun with the old school tech in my current game. I've been trying to get into some graphic stuff, but there's always something more important that takes priority. Yeah, probably. Yeah, I'll let you know how it goes. I'm going to go through this VK guide. If I come out of it being like, okay, yeah, that's pretty reasonable, then yeah, I'll let you know. And so far, it's definitely way better than the learnopengl.com. I don't know. Maybe I'm just sensitive because I write books for a living, but yeah. Other code initializing the Vulkan device. So we're way down here. All right. Graphics queue equals VKB device get queue VKB queue type graphics value. Okay. And then graphics queue family is VKB device get queue index VKB queue type graphics value. Oh, Blowfish. I see what you're saying on the value. You're thinking if I look at this function, get queue index, it'll return an optional. Yeah, we can. I have a quick way to test that. Let's compile this. Yeah, I'm not sure why they're doing it this way. Can we do let's try like a new style. Did that succeed or fail? Did it fail? Where you fell? Too many U's in Q. Okay, success. Now, so this is the question. Let's try. Let's do string. That fails. Conversion from VKB result. No, it's their own. It's his own invention. Debug vector VK image T. Yeah, nah, it's his own invention. Okay, success. Let's confirm it runs without crashing. Ta-da! It runs without crashing. Okay, next step. Okay, so we have the queue, we have the queue family. Now we have init commands. Init commands. Okay. VK command pool. I'm going to grab these comments and just kind of copy them in there. Command pool create info. Command pool info equals this. All right, command pool info dot s type equals this long ass thing. Okay, I'm just gonna copy it. Info. And then command pool info dot p next equals null pointer. All right, command pool info dot flags equals veep. That's another long ass one I don't feel like typing. All right. Command pool info q family index graphics q family. Okay, so that sets up the info. Then we do int I equals 0, I is less than frame overlap I plus plus. Okay, VK check. VK create command pool. All right, we have the device, so the VK create. So we create command pools on devices, not on the instance. Interesting. So you could, yeah. So the way this is structured with Vulkan, you could have like 100 GPUs, right? You'd get the physical devices, then you would grab multiple virtual devices from them, and then you could create command pools on them. Yeah, I'm going to say Vulkan is kind of like the API for the AI era. That's totally marketing dude style. But yeah, so like you don't have to render to a visual thing. You can just run GPUs with never render, right? And you can grab as many devices as you want and add as many command queues as you want on them, and there you go. Right. Command pool info. And then we need the address of the frames. address of frames I dot command pool. Okay. And then vk command buffer allocate info command alloc info. Okay, so alright, we'll just assume this is kind of the same shit, so I'm just gonna copy pasta this. It's okay. I'm sure it won't cause any problems. Alright, so then you create command buffer allocate info. Level primary, okay. Alright, I'd have to learn what each of those things are, but that's fine. And then you allocate it there, and then vk allocate command buffers. So you create a command pool. Oh, for each frame, okay. Per frame, you have a command pool. And then you allocate it. Okay. All right. Format is not declared. Oh yeah, that's right. String vk result. String vk result. Where the hell does that come from? Oh, this is missing. Well, we'll see if it's missing. Yeah, we do not have this advanced technology. Well, shit. All right, we'll have to find that. We'll do that. Just convert it to an integer, and I guess we can try to look it up. Okay, so far so good. Okay, so we have our command buffer set up. Let me see. Very important we do this, okay. The compiler initialize this entire struct to 0. Where are we doing that? Ah, okay, we zero it out. No problem. So, okay, we set the Q family index. I mean, honestly, this is all understandable code. I think this is the thing, is like when I was doing OpenGL, it's just like everything was disconnected. There's just like this internal state that you're manipulating, and nothing makes sense in the code. Whereas in the Vulkan stuff, yeah, like it's complicated, right? But it's pretty logical. I create a command pool. I configure the command pool. I create it here. I attach it to the frame. I allocate it. There you go. There's a lot of code to do that, but I mean, it's logical. It makes sense. Whereas like OpenGL was like all over the place, man. Some parameters at the end, some parameters at the beginning. No consistency. Let Vulkan know that our parent is command pool. Okay, now assuming we did that correctly. If you want to remember the article that explored the project files, we commented that the VK initializer module will contain an abstraction over initialization of Vulkan structures. Let's look in the implementation of those two structures. Wait, where does this go? So we can just make that? Okay, where does that go? Okay, so we look in VK initializers. Okay. Okay, since I already did this code, let's do, so where's the header on that? Okay, so it's just in a namespace. There. Okay, so that's in a namespace and it returns create info. Okay, so because I'm imagining you have to do that a whole bunch. Oh my god, I gotta fix that. Okay, I'm gonna do it this way. This is dumb. Alright, we're just gonna grab this and then move it out. Okay. Then we can get rid of that and that and this and that. Is this in the header we're defaulting that? I think we default that. Yeah. It looks like that's what's going on. Okay. And then back at the init, yeah, that cuts down on that code quite a lot. Back in our engine, we just do this code. And I'll just copy that since I basically did all that already. Okay, so now we have a couple of helper functions. Yeah, because I bet you're going to have to create these command buffers all over the place. Okay, make sure it runs. Okay, so far so good. Yeah, all of that makes sense. All right, now in the cleanup function, we have to do cleanup. If is initialized. I'm guessing here. Okay. VK device wait idle. Well, that's just a timing mistake. Waiting equals 0 is less than frame overlap. VK destroy command pool device frames I command pool null pointer. Okay. Anything else? No, that's it. We're almost there, folks. We're at rendering loop. I don't know what we're going to render, but hey, it's been fun so far. Okay, Vulkan offers explicit sync structures to allow the CPU to sync execution of the commands with the GPU. All right, I'm going to sit down. I'm standing this whole time. All right. Once you send some commands to GPU through a queue or other method, those will have no restrictions, and the driver GPU will execute them as it sees fit. Okay. VK fence, this is used for GPU to CPU communication. VQ submit, allow an optional fence parameter. If this is set, we can know from the CPU if the GPU has finished these operations. We will use it to sync the main loop in the CPU with the GPU. The fence will be signaled once submitted as part of a command, and then we can use VK wait for fences to have the CPU stop until those commands have executed. We will have two fences, one for each of our frame data structures. Okay, so you submit, yeah, it's a web server. It's a web server. Could it be that graphics people hate Vulkan because it makes them learn how a network server works? I'm over here doing this, and I'm like, yeah, it's a web server. I don't know. It's a TCP IP server. Submit, request, get response. There we go. VK semaphore. This is used for GPU to CPU sync. Fence, some operation, my fence, wait for fences. Yeah, async await. All right, no problem. Give the semaphore acts as a link. Pseudocode example, linearizing 3 operations. Semaphore. Okay, so it's got some semaphores on it. Okay. Given semaphore acts as a link between multiple GPU queue operations. One operation must signal the semaphore, the other operation must wait on it. Okay, so this is how you can make sure that they happen in a sequence if they need to happen in a sequence. Okay. Three things in strict order. Okay, render loop. For our render loop, we will use double buffered render structures. This way, while the GPU is busy executing a frame worth of commands, the CPU will continue with the next frame. Once the next frame is calculated, we need to stop the CPU until the first frame is executed so that we can record its commands again. We need to synchronize it with the swap chain structure. If we were doing headless drawing where we don't need to sync the screen, we wouldn't need this. But we are drawing into Windows, so we need to request the OS for an image to draw. Image layout. GPU store images in different formats for different needs, blah, blah, blah. Chain layout of an image, Vulkan does pipeline barriers. It's a way to synchronize the commands. To get the transitions right, it is imperative you use the validation layers, which are going to check that images are on their correct layouts or any given GPU operation. If you don't, it's very common to have code that works completely fine on NVIDIA hardware, but causes glitches on AMD or the opposite. The image we get from the swap chain is going to be in an invalid state, so if we want to use VK command draw on it or any other operation, we need to first transition the image into a writable layout. Once we are done with the draw commands, we need to transition it into the layout that the swap chain wants. In older versions, this will be done as a render path. We were on Vulkan 1.3, and we use dynamic rendering, which means we will do all those transitions manually on the other side, save all the work and complexity of building a full render pass. Render passes, the older version of the tutorial, is there. Okay. All right, the first thing we need to do is add the synchronization structures that we're going to need into our frame data structure. VK semaphore, swap chain semaphore. I don't like that. VK semaphore, render semaphore. Okay, so these are blocks between individual things. VK fence, this render fence. Okay, we're gonna need 2 semaphores in the main render fence. Yep, makes sense. All right, and that chains one after another. Okay, this is just a network server. That's what it is. It's a network server. Makes way more sense. Imagine I learned something new. Jeez, the horror. I know, right? Yeah, it didn't. How was it doing your Rust network protocol? Was that too hard? I heard that doing network stuff in Rust is actually kind of difficult. Because so many of the low-level APIs need you to like share pointers to things. Okay, so in the VK init initializers, we're going to make these. Okay, so VK fence create info VK init fence create info VK fence create flags equals 0. Okay. Hello. The fuck? Okay, there we go. VK fence create info. Info is this. Info.s type equals VK. Info.p next equals null pointer. Info.flags equals flags, and then return info. Okay, so we have that. Next, we need the semaphore create. VK semaphore create info VK init. Same thing. Flags equals 0. VK semaphore create info equals this. Info.s type VK structure type semaphore create info. Info.p next equals null pointer. Info.flags equals flags. Return info. I feel like that can be done differently. I don't know why. Alright, we'll do it that way for now. It's very simple, but I already used sync channels quite a bit, so that part I think of it was a lot of the trickiness to be able to route out of order responses to whatever waiting. Okay, you didn't use Tokyo? Yeah, that's the thing that in Rust you use, right? I prefer more verbose sync code, but I feel I have more control over it. Oh, nice. Okay. All right. Yeah, I've never used. Oh, this also should be VK. Let's see. Fionical fence create in off. No, that's totally correct. How dare you accuse me of getting that wrong? Thank you for the fix. Yeah, I've never used Tokyo, but it's sort of like an async await IO library, or is it like a green threads thing? Okay. Okay, so that compiles. Now, init sync structures. Init sync structures. We do for int I equals 0 as less than frame aim overlap Okay, VK check. VK create fence device address of fence create info null pointer. Address of frames I dot render fence. Okay. Next one is VK check. Okay, we create the VK create the two semaphores we need. Again, pass it the device. Semaphore create info null pointer address of frames I underscore swap chain semaphore VK check VK create semaphore nice address of create info null pointer address of frames I dot render semaphore. Okay, so just basically creating request response timing restrictions. All right, that's not that hard. OpenGL is very easy. I am sorry, man. I was doing OpenGL. It's batshit crazy. It's just all over the place. You do have to do a lot more in Vulkan, but this way makes way more sense. It's way more sense. OpenGL is just a bunch of like random crap behind the scenes. Fence create info, right? Oh, interesting. Oh, I'm missing like a whole set of variables. The fuck? VK fence create info. Fence create info. VK init. Fence create info. VK fence. VK semaphore create info. Semaphore create info. Okay. Starting to pair async, await IO runtime framework. Yeah. Rust async doesn't feel nice like JavaScript async. Yeah, I thought they modeled their async after JavaScript's. Personally, I feel like JavaScript made a massive mistake, and I think Rust may have copied it. They should have done it where like any function that you do fat arrow, right? So you do like oh shit, so if you have function thing, right, that's old school style, and you have to add the async on it. Okay, what they should have done is they should have said if you do say like this, and I'm completely forgetting my syntax. Functions like this are automatically async, so you don't have to do anything on it, and then every function call inside it automatically gets an await on it. So everything is awaited, because that's 90% of your code. You're putting an await in front of everything, and then if you don't want it to be, you want it to actually be, you know, like deferred basically, then there's a defer keyword. So when I do this, that's awaited automatically. Do those. Those two functions are awaited automatically, and that one I defer. Because this in modern JavaScript code, you almost always are going await. You never are like deferring it like this. So it's like incredibly rare, right? And also I find when people are doing like, oh, well, I want to put it into like a group, and then they have the group, they're over optimizing, and almost all the time that's not helping, right? So I think that's what they should have done. They should have said, when you do it like this, it's old school style, async await, you have to do everything manually. When you do it like this, it's automatically considered async, and every function call in there, if the compiler knows that this is an async function, it automatically tags it with await. And that way you don't have to type await so much. Makes it work more consistently. I agree, colored functions are awful. Well, and also it leads to a bug. Like if you do this, if you do like let x equal that, that's a bug, right? So the purpose would also be, one, to avoid the annoyance, but two, to solve the bug. Because what you get from this is a promise. You have to do await on that. See, and that's really, really bad. It should be, if I'm inside a function, I'm just calling it like normal, the compiler knows, it knows it's an async function, it has the type, it has all the info. It should just go, okay, we're just gonna wait on this automatically. And then if I defer it, it's assumed I know I'm getting a promise back. So I know what I'm doing, right? Because I get bit by this all the time because I'm expecting, you know, normal function calls. Oh, that one's async, that's why. And then when you try it, you go x dot do thing, and you get a weird, because that doesn't exist on promises. I think the other thing that JavaScript should do, or TypeScript, one of them, is it should make promise a strict object. So promise can't be altered, it can't be added to, it can't be extended, and if you call anything on it that's not on promise, you get a solid error of attempting to call do thing on a promise. Did you mean to call await? Right? So I think Rust copied that without really thinking through it, right? And you have a promise instead of value. Yeah, I think Rust, they copied through it. And I read one of the people who worked on it. They're just, you know, for like 500 pages of blog posts, they're waxing about all the reasons why it had to be async await. And I'm like, yeah, but you could have defaulted to everything being async, and then defer is the keyword. And if people want the defer, which almost 90% of the time they don't, then they just use the defer keyword to get it to it, which fits with Rust's theme, right? Like everything is const, right? The safer option. So it would make sense that everything would be async. VK semaphore create. Yeah, here. Frames is not declared. Oh, it's that. Right? No. Yeah, that. Okay. Address of, yes, okay. I'm missing a for loop. Okay, success so far in its sync structures. Okay, now hold up. Make sure that runs. Cool. No crashes. No crashes. Okay, and now we do draw. Okay, VK check. VK wait for fences device 1 at get current frame render fence. Okay, yeah, that makes sense. True, I'm assuming that's some kind of heinous default weight amount. Okay, and then VK check VK reset fences device address of, yeah, okay, get current frame render fence. Okay. We use VK wait for fences, wait for the GPU to finish its work, and after it, we reset the fence. Fences have to be reset between uses. Okay, yeah, that makes sense. It's kind of like semaphores and stuff. Next, we're going to request an image from the swap chain. Next, where? Where are we doing this? Okay, I'm assuming it's uint32t swap chain image index. Okay, check. Acquire next. Okay, how many zeros is this? Hold up. I'm just assuming that's some sort of weight parameter. Get current frame. Was it swap chain semaphore? Yeah. Swap chain. Swap image index. Okay, so that gets us a swap chain image index. Let's default that to 0. Okay. Check how we are sending swap chain semaphore to this. Make sure we can sync other operators with swap chain, having an image ready to render. Okay. Time to begin the rendering commands. For that, we're going to reset the command buffer for this frame and begin it again. We'll need to use another one of the initializer functions, VK begin buffer. Okay, I'm just going to copy pasta that. It's pretty much the same stuff. I feel like there's a better way to do these. I feel like there's another style. Let's see, sorry, yeah, it's way more common than you always await on a future than creating the future and then dealing with it later. Yeah, and it's always, yeah, you're right, some parallelized group, and then always when people are doing that, I find that they're causing more performance problems because then they aren't figuring out the coordination, then they add some like kind of semaphore, and then it gets worse because of the coordination and blah blah blah. Okay, VK command buffer get current frame main command buffer. Okay, VK check VK reset command buffer command 0. VK command buffer begin info. Command begin info equals VK init command buffer begin init. This is a lot of shit to do. It's kind of funny though, because then when you're done, you can do anything you want. It's kind of funny. Oh, yeah, yeah. There you go. Wait, what? Wait, how did that compile before? I should have failed earlier. Maybe it did and it just didn't notice. Okay. Command buffer is in and not a member of. Okay, what did I call it? Okay. Oh, it's probably begin info. Okay, yeah. Yeah. All right, great. Okay. Oh, man. All right, let's run it. Confirm it runs. All right, so now. And we clear the buffer. This will completely remove all commands, free its memory. We can now start the command buffer again. Okay, wait for fences, reset fences, acquire next image, main command buffer, reset the command buffer. All right, command buffer info, begin command buffer. Yeah, it's transactional. It's pretty wordy, but this is basically like if you're going to do a transactional, database, right? Begin and commit. Okay. With the command buffer recording started, let's add commands to it. We will first transition the swap team image into a drawable layout, then perform a VK command clear, and finally transition it back for display. This means we are going to need a way to transition images as part of a command buffer instead of using a render pass. So we're going to add it as a function on VK images. Alright, we don't have this yet, so pragma once include Vulkan vulkan.h namespace VK util, and in the interest of time I'm just gonna copy that. Alright, and then VK images.cpp, and we're going to wait, no. Wait, what? Wait, so oh, okay. Okay, kind of weird. All right. VK, what did I call that? Images. VK images. Wait, what? Yeah, this is VK images.h. I'm guessing that gets included in VK initializers. Okay. Weird. Include VK images.h. Okay. And then VK util, and then VK images.cpp. Let's make this empty, and then we can construct it manually to learn how it works. All right, and then I need to add that to my build. Hey Andrew, how's it going? This is cool. Last stream being OpenGL. Yeah. That was kind of the idea. I'm trying to see which one I like better. So far, I like Vulkan. I have no idea what I'd use it for. I think at a certain point I'd get annoyed and just find something easier. But you never know. I mean, I do like doing things the hard way. Here we go. VK images.cpp. Alright, that's that. Okay, let's get that to compile. It'll have errors, but that's fine. That build? I know where that built. Let me just make sure. Alright. I call bullshit. Okay. So now, let me see. VK imager barrier. Why are they doing it this way? I don't understand. Yeah, why would you do that? Do an initializer like this and then also set these later. Okay, all right. Okay, so we have VK image memory barrier 2 image barrier s type equals VK. Okay, that's a lot of crap to type. Aspect colored bit depth. Yeah, let's just grab that. Alright, I think I'm going to change up the music as well. It's been fun, but... let's go lo-fi. Yeah, let's go jazz. There we go. Back to normal. What? Okay, I don't want to get this wrong. Okay, I'm gonna grab... Okay, so these are just setting options. Okay, so let's do that. Right, so it sets just various options. Access to memory write bit, pipeline stage 2 all commands bit, memory write bit, a word with the memory read bit. Okay, I probably have to read the description of all those options. Okay, and then we do image barrier old layout, current layout, image barrier new layout equals new layout. Okay, so image aspect flags. We didn't make this function. Did I miss something? I feel like I missed something. Yeah, where's this init sub-resource? Ah, there it is. Okay. Again, it's just another initializing a struct thing. So let's do vk init. Paste that in. Okay, cool. That goes there. What? Hold on. Okay, so that'll initialize that, and then yeah, I should have made that before we did this function. Okay, we determine the aspect flags, and then vk dependency info dep info info.s type equals vk. We'll just copy that. I don't want to get that wrong. Dep info.pay next equals null pointer. Dep info.image memory barrier count equals 1. This is a lot of stuff to type. Hopefully you don't have to do this for like everything. Like, can you imagine if you, hopefully this is just all set up, but if like everything you wanted to do involved this insane chain of structs. But it really is like it's basically a transactional API, right? So this is creating transactions. I feel like you could abstract this away with like a begin transaction, end transaction thing. Yeah, I feel like you totally could. Barriers. Okay, we have the next part. Image sub-resource. Okay. Now we can finally transition the image. Okay, so now back in VK engine. Well, let's just run what we got so far. I don't know if I've run actually. All right, yeah, cool. Okay. With the transition function, we can now draw things. Okay, so we have to add VK images to the includes. Oh, okay. Got it. Okay, and then we do that, and then we now draw things. Where does this go? Where's this code go? I'm assuming it goes in draw. Okay, VQ util transition image command swap chain images swap chain image index, and then there's a couple of options. Image layout undefined, image layout general. Okay. So don't get those wrong. All right. Make a clear color from frame number. This will flash with a 120 frame rate. Okay, VK clear color value. Clear value. Float flash equals absolute standard sin frame number divided by 120.f and 0f. Clear value equals 0.0f, 0.0f, flash 1.0f. That's a 4-color value. Okay, VK image sub resource range. Clear range. Okay, okay, we'll just do this. We almost have something drawing on the screen. That was my goal for today. Let's see, what are we at? 4.5 hours. Vulkan is the reason Linux gaming has been taken off. Kind of. Actually, DXVK. GitHub DXVK, which takes the DirectX APIs, like I think all of them, going way back, and then basically translates them to Vulkan calls. So that you can pretty much just kind of like drop these DLLs in and boom, it just runs. That's been a big part of it. Plus, Steam dumping like money and people on the Proton project, which is basically allows a lot of Windows programs to run. Yeah. So basically, and then weirdly, I've seen a few reports where they say like on Linux, a lot of PC games do better, have better performance. Not a lot, like 4 or 5%, but that's amazing given that it's basically going through a translation layer too, right? All right. VK image subsource range, VK command clear color image, swap chain images, swap chain, lowercase swap chain. Swap chain is one word. Right, and then we have VK image layout general address clear value 1 and clear range. Okay. And then VK util transition image command swap chain images swap chain image index and swap it over. VK image layout general present source KHR. Okay, it's a lot of weird little options, but okay. It's kind of easier to understand stuff once you've typed all the code in. VK check, VK end command buffer. It's a transactional API. Begin end. That's what it is. Yeah, look. If you ever do database, right? Begin command buffer. Do stuff. End command buffer. That's it. I don't know. And then you're doing basically like it's like a network call. All right, we'll see if this does anything. We'll see if it does anything. Fraydex. Hello, been lurking on the stream for a little while. Working? Interesting stuff you're working on. What are your thoughts on someone working as a front-end web dev but ultimately wants to work in game programming? Just go for your C++ course and hope for the best. Yeah. I don't think, I mean, I'm kind of proof that you don't have to be good at the math and stuff to make a game. I would say being good at art is probably a better indicator. I'm forgetting something here. BK image that date. I would say learning art skills is going to give you way more bang for your buck. Even if all you do is just learn basic drawing or like Blender, anything like that. Is going to give you way more bang for your buck than like a lot of like the math and stuff that people say you need. Because honestly, like my ability to do painting has been the reason why I've been able to make my game more than anything else. But yeah, I would say like probably get your feet wet with something a little simpler. Like I would recommend Love 2D. Here, let's pause this for a sec. Let me drop some knowledge on you. Just try making a really simple game, and it could be a copy of a game like Space Invaders. I did Rogue, so I'm a big fan of Rogue as kind of like a first project, because it's like really very programmer oriented, all done in the terminal, right? Super easy to work on. You don't have to be good at graphics, at math, nothing. But you learn all kinds of stuff like pathing algorithms, everything. And then if you do, my C++ course isn't done. That's why I'm saying don't do the C++ course. There is no C++ course. But if you do the Go course, at the end of the second module, you do a little game, a little Rogue game. Which is here. Yeah, this guy. And it's not a lot of code, and you get kind of like a sweet little terminal game that you can then continue on with your stuff. And I can actually show you how it looks. Projects, let me see. Blah, 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 blah. Curse you. And let's see. 05. Yeah, so you see? So you learn how to make like a randomized maze with rooms, place enemies, and also path the enemies. So if you can just like start working on something like this and kind of tinker with the stuff for a while, you'll learn a lot about sort of like the things that really matter more, like game mechanics, algorithms, how do you store data, how do you manage the data, how do you make the game interesting. Graphics, you know, like they matter in a lot of ways, but I think core mechanics and whatnot are way more important. And I'm trying to get an enemy to follow me so I can show you that I have the pathing working. Yeah, so see that guy's following me? Yeah, it's a really simple algorithm, but it turns out to be stupid useful. So that gets you started, and then from that you branch out into adding graphics to it. So I sort of did the same thing. I did that, and then I did this. This is basically a graphical version of the same thing. Right? So this is a graphical version. I did in C++, but you can do it in almost anything. And then I did this guy. And this was like, I just wanted to learn how raycasting worked, and then I just kept going with it. Like, just kept pushing it and pushing it and pushing it until I have a game. But this is basically the exact same. It's very similar to the Rogue game. But all I do, because they all work on a grid. So these little grid-based games are very easy to work on. Make it turn-based, make a grid, and then you got it. And go like that, and there you go. You can see it's basically the same game. But it's evolved quite a lot. And pretty much like game dev, and it's not magic, man. And when you start looking at like how a lot of these graphics APIs are done, yeah, I would say that Yeah, a lot of game dev is just smoke and mirrors. Now, making like graphics engines and stuff like that, sure, yeah, you do need to know quite a lot of the math that they say you need, but you just want to make like a basic game. Nah, you don't need to know that shit. I'd say art is way more important. Way, way more important. Shader Theory, welcome back. Game engines is then the game mechanics. Vulkan, yes, I'm trying out Vulkan. You're 1.3? I think I'm doing 1.4 right now. And let me see. Yeah, FredX. Yeah, try it out. I'd say start small, you know, and really just work on like, and also doing copies of games is a big deal. I'd say that's probably the easiest way to kind of get into it. Find little games, keeping it small. That's another thing too. But in general, yeah. So you said GPU is your B word. Don't give up. I'm having fun. Yeah, it's pretty logical. Like things go and are constructed, and there's yeah, it's a transactional API. That's nothing bad. Now doing more than the tutorial. I don't know if I could. Game programming might mean gameplay programming. Math is probably not as important. Nah, yeah, I'm not sure what you mean, Arthur. Let's see if I did a game dev the hard way, which language? I don't know. I'd have to sit down. Lua is a top contender. Definitely. As something I should also mention, Freya's what your name was? Yeah. Love 2D is really great. I mean, lots of really great games are made with it. And if you look for, here, let me actually go back one more time. Let me get you this tutorial. They make a few little games with Go, right? Go's simple. It's simple enough, whatever. Anything, JavaScript, whatever you know, it doesn't matter. And then if you want to get into Love 2D, then there's Meeple Love 2D. What the hell is the name of that? Sheepolution. This is a really good tutorial on it. Really good. Very easy to work with, and this tutorial pretty much takes you through like all the stuff. And you make a little platformer game. Yeah, we just go through that and go to town. You Metal 4 on iPad to make ray traced voxel game. Nice, man. And you're doing Rust now? That's cool. I'll get back over here. Key toggle. DJ Girth. Is AI any good for game dev? I don't know. I mean, what was that game that got caught doing a shitload of AI? It's a shooter game. Just came out recently. Got terrible AI art and stuff in it. Game companies are so desperate to just shit out turds and hope that it catches on as a live service game. This is so desperate to get on the live service train. They're like, ship it, AI. Anyways, okay, we have a VK pipeline barrier. Did this compile? I doubt it did. VK init has not been declared. Why have you not been declared? Wait, what? Okay, yeah. Hold up. I feel like these functions shouldn't be in their own thing. Initializers.h. Yeah, I feel like these should be one thing. Because you're kind of seeing this sort of deadly embrace of the two. But anyways. Okay, here's a description of it all. Okay. Let's run it. I don't know if it'll actually show anything yet. No, it doesn't show anything. Core dump. Core dump. All right, do we have a problem or is there more code? Now have a fine command buffer that's recorded and ready to be dispatched to the GPU. We also need to connect synchronization structures to the logic for the logic to interact correctly with the swap chain. Okay, we have Z-Crash. Let me raise my desk. Pixel art. I knew about Love 2D. Thanks for your tutorial. Yeah, that tutorial is pretty good. I read Love R. Yes, but I don't have much of a use for Love R. Okay, let's figure out why it's dying, if we're just missing more of the tutorial or I botched something. Vulkan draw at 74. VK engine 74. Wait for fences. I think we're missing an initialization step before the draw. Clean up and knit. I think in here we're missing something. Vulkan swap chain commands. All right, let's confirm I got that line right. Also, this function has been built over like 5 code blocks, so I don't know. Okay, we're just gonna grab this just to confirm I didn't make any mistakes. I feel like we're missing an initialization step. Yeah, I feel like there's something missing. Sig abort. Oh, is there an error from the... Hold up. Aborted. Okay, we're getting an abort for some reason. I predict that will be very difficult to figure out. Wait for fences device. We've initialized the device. Well, wait, is this timeout here? Does it cause it to abort if it reaches the timeout? Is that what that's doing? Okay, let's continue with the tutorial. I suspect we're missing either an initialization step. Yeah, we're missing something in either the initialization or this is effectively timing out. You know, one way to test it, let's make it time out quicker. And then it aborts if it times out. It's kind of weird. Okay, so if it crashes quicker. Okay. No, it's the same amount of time. Okay, so for something isn't being configured correctly. But also this function is built up over a bunch of blocks across like, yeah, like this, and then a few other things. So it's possible that there's missing code. Also, where do we call this? Am I calling that? Hold up. Yeah, it's been called there. What do we initialize? We called that. Okay. Is it possible I'm getting this wrong? Frames I, render fence, render semaphore. Yeah, this is basically the GPU or the Vulkan driver is aborting without an error message, which is weird. Look at this. Oh no, yeah, we're getting this. This is giving us an error. And then calling abort. It's this. Okay. We don't have the thing that tells what that is. But why am I not? It's getting detected Vulkan error. Probably because it's calling abort before then. Let's just do that. So I think we're missing more of the tutorial. Yeah, okay, it is that, but it's not printing anything, so... screw you, man. Let me see. Alright, we're gonna rewrite this. This is not how you do this. We'll do that. That'll guarantee us. We don't know what the error is, but I think that'll do better than what we had before. Oh, and we have to do this trick. Alright, we can work on that later. Yeah, it's not outputting anything. Yeah. So we're getting some... So we're going to resort to old school trickery. Oh no, there we go. There's the Vulkan. Yeah, no, it's most likely buffering. There we go. Vulkan error 2. We do want that. We want that error to be flushed. And not being able to get like the names of those errors is pretty bad. Error handling is always, okay, cool. Yeah, I'd rather have it do that than abort, to be honest. Let's try this, actually. No, that wouldn't work either. Okay, well that gives us something. Alright, I suspect we're missing a few more parts of the tutorial, so let's continue on. Vulkan error 2. I don't know, because like that's coming from an enum. We'd have to go find the enum, and there's I guess some kind of library that I haven't been able to find that gives you the names, which should just be a stock part of the library to begin with. Alright, so this may be the death of today's stream until I can come back. Maybe it never runs. But see, this is a pretty important function. I'm not sure why he's cutting it up so much. Yeah, like it's not. It's dying. Where does it say it's dying? Oh, you know what? And also, yeah, it'd be better if there was like a line number. Yeah, there's a lot missing from that VK check thing we could add. Okay. Let's go draw. The fact that it's dying right there tells me that something is not being correctly set up for that render fence. So let's look at this init sync structures. Render fence, this. I feel like that's wrong. Let's go init sync structures. And let's do this. Let's just copy paste that in, assuming I made a mistake of some kind. And then I'm kind of curious what the difference would be. Let's do that. Let's do this. Let's compile this. Nope. Yeah, no, it's an error. It's still an error. Yeah. Okay, that tells me that either we have more we have to do, or, but see, if there was more to do, then this, it wouldn't die just right when we try to wait on the fence. Let's see. Or a built-in trap. So you can see it in GDBs. Like, yeah, something like that. I have some sauce I can use that does a better output. Okay, so it's not that init function. Alright, so it's dying on the VK wait for fences. And so far as I can tell, I've set everything up. Okay, so on the fence, we're using the VK fence create signaled bit. Yeah, that's all there. I copied that in. Wait for fences. Yeah, and that dies though. Okay, let's continue. Maybe he mentions it. Okay, we got the sub-resource range. Yeah, it's not even getting this far. Okay, with clear command, this we now find command buffer. No, I feel like there's a mistake somewhere. We've probably done it, but I bet this is missing some code. Okay, so let's look at the VK init initializers. Semaphore submit info, buffer submit info. Yeah, this is more just like the kind of strange structure initialization that he's doing. I feel like there's a way better way to do that. Okay. Okay. Okay, we have those. He doesn't explain where he's putting these. I'm assuming it's like at the end of the draw function, but like he should have made separate functions for each of these parts, and then he'd create the functions. So that's what was been going on so far. But I feel like yeah. Yeah, like draw is getting large, and he's not explaining where this goes. Submit info arranges everything together. Okay, cool. It links to this back for those structures. Yeah, all right. So this is the big problem with this style of writing is that these disconnected chunks of code just kind of like go out in the middle of nowhere, and like, okay, where does this go? Does it go at the end of the draw function? So we can sort of kind of figure it out. We have the command. Yeah, it's got to go at the end because you have the command. But see, it also means that none of this will really work. All right, I'm just going to copy this. We're going to see if we can at least get this to work, and then we'll back up some. Because as far as I can tell, there's some component missing or something that I didn't quite see that's making it so that it doesn't initialize the fence first. Or last thing we need to do on the frame is to present the image we have drawn to the screen. Yeah, these should have been separate little functions. It should have honestly just been a sequence of functions. This is kind of difficult to figure out. All right, so now paste that. Let's just confirm this even runs. I don't think it will. I think it won't run. There's something that we're missing on the fence. With this, we have the draw loop done. The only thing left is to clean up the sync structures. Probably a part of it. God damn, man. Wow, that's a lot of shit. But where does this go? As part of the cleanup function. Okay, so then this goes in the cleanup function. Yeah, it's not going to run. It's not going to run. No, yeah, it's not going to run. Frame overlap in here. So this is destroy the command pool and destroy the sync objects. Here. Oh. All right, so we're missing some crucial piece of initialization info for the render fence. It's causing it to abort. All right, let me see what we got. Do we get an error? Odd. So I wonder if that timeout. By the way, success. I made a window in Vulkan. Look at that. Okay, so I think that error message has been a timeout. Like you're telling it to wait. It's like, I got nothing to do. Because once you load it in, which makes sense, because if you're doing semaphores or any kind of like transactional APIs, and you add a timeout, then you get an error when the timeout ends. So I'd have to go and see what that error is. But that would mean like, that's not very robust. I could see it where like, maybe your GPU gets choked on something for a bit, right? You wouldn't want like your app to crash. You'd want to go, the render fence is busy or something, then do some other work, right? But hey, we have it. It is working. Let's see where we're at. It's not too bad. That's a lot of shit. It's a hell of a lot of shit. Yeah, I definitely want to go back through draw. Okay, what are we looking at? Transition the image. Okay. Yeah, this should be, I think what I would do is similar thing that I did with the OpenGL example is to basically refactor this code a bit, because this should be separate, that should be separate. Each of these should be separate things. Also this weird, like, is there something I'm missing? Like, why can't we do this? I mean, C++ is not as good as C when it comes to this, but can we just do this? And isn't it anything I don't set is guaranteed to be initialized to 0? Yeah, the order is messed up. Which is just the dumbest error. Like, there's a reason I have a compiler. It figures that shit out for me. Just reorganize it. You know the order. Just change it, right? Like, making me sort out the order is just awful. Yeah, if you could figure out how to do this, you could make this code a lot nicer. We'd have to go look at the structure, but if like it's something like that or something like that. But now if it's this, but then there's like an ass load of other things after it, like it's like 17 other things, I guess those would all get initialized to 0. But if it's more like, let's say like, it's like that, there's like 4 things here that you don't initialize, then C++ can't handle that. It's no way it's going to handle that. Yeah, I'm almost positive there's a way to kind of do this better. All I know is you need graphics to make video games. No, you don't. You don't need any graphics to make video games. You can make incredibly fun games with just some text characters. All right. Well, that's success. Let me see. What do we got? 5 hours. And I had to copy paste towards the end just to confirm that I didn't have a bug. All right, I'm going to do this. Let's grab this so I know where we are. All right, let's go. Okay, there we go. All right, I got a little Vulkan engine going. It's not too bad. I mean, it's definitely leveraging the VKB thing. I imagine if you had to do this stuff that VKB, this device builder, if you had to do that, I bet the code behind this is just heinous. I bet it's just monstrous. But as far as like, and then this draw loop is is nuts. I'm already thinking of a couple ways you could probably make it a little bit more palatable. Yeah, I'm thinking there's a couple ways you can make this a bit better. It is just a transactional API. Yeah, there's a few ways you can improve this. Yeah, getting rid of this kind of shit, like figuring out how to initialize these structures in like a more modern style, if it's possible. Pulling these up into separate functions. Yeah, that kind of thing. Error 2 was, I suspect, once I actually made it do the remaining part of the render, which is this part down here, which is creating the buffer info, the submit info, and submitting the actual work to the queue, then it started working. And I suspect what 2 is, I have nothing to do. Right? Because you add a timeout of 1 second here. So wait for fences 1 second. Anytime you have any kind of like semaphore or any sort of like locking primitive, if you give it a timeout, they almost always report with an error of some kind, which is like, oh, hey, timeout. I didn't have anything to do, timeout. So probably the VK check, it doesn't check for that being like, that's kind of a non-error, I guess, you know, is a way to say. So because it didn't have anything to do, I think that timeout is. But I'd have to go look at the header file, find out what the hell that error code is, and then translate it. The fact that there's no, like, you know, in the C API, there's a print error and str error. They need that really bad. Like, can you imagine trying to debug it with just like raw enums? It's fucking terrible. There was a library, but I don't have it. I have to go find it or something. Anyways, it's working. Let me see if we can get it committed, and then oh, I don't have it. I don't have it online. Okay. All right, folks. It's been fun. Let's try it again. Make sure it works. There we go. So if I'm thinking with compared to OpenGL, I did OpenGL for about 5 hours. Yeah. It was probably like 2 hours one day, 3 hours the next, something like that. I'll have to look. I have to look. So it's about the same amount. I'd say VK Guide is way better written. Way better written. It needs to work on the setup part. The setup part's not good enough. But once you're set up, yeah, it's really logical. I'd say Vulkan is way more logical. You find a device, you get a virtual device from it, you submit commands to it. It's a pretty wordy API. I very much think they should have iterated on that part a bit more. But yeah, as far as like, but yeah, it's really logical. It seems to me like the thing is, OpenGL is sort of like this spooky action from a distance, random ass functions over 20 years that control some like opaque state machine, right? So that just bothers the shit out of me. Like what do you mean this is just, I just do things and stuff happens? That's weird. Like, well, what am I modifying? What am I changing? Whereas Vulkan, like, you go, oh, I'm changing the instance, I'm changing the device, I'm adding the semaphore to this. That's all like makes sense. That's kind of standard, you know, transactional API stuff, right? So I think my view on it is Vulkan is kind of like a request response, like almost like a network API to the GPU, right? You just like the device could be considered a port on a web server or a server or something, and you start a transaction, you send data to it, you get the data back, you view the data, you close the transaction. Yeah, I mean, that's pretty much all it is, right? Which I can see, like, game developers are sort of notorious for not knowing how network protocols work. I mean, let's be honest. How many of you have seen people hacking the network protocols on games? It's constant. So I suspect that's actually probably the reason why it's considered difficult. It's wordy as fuck, but the actual model seems to be pretty logical and straightforward. Whereas the model for OpenGL is just batshit weird. It's like all over the place. Now that could also be that just that Learn OpenGL tutorial is weird, and actually OpenGL can be explained way more easily, right? I'd totally be valid. I think that's fine, right? But this Learn OpenGL definitely a way, or VK Guide, way better written, way better. OpenGL code won't tell a beginner what is happening by reading the code. Yeah, that's a really good way to put it, where it's like, you know, you make a VBO, and then you make a VAO, and then, ta-da, like, you just do stuff and it gets connected. And that's like a no-go, man. Like, it's way too hard to work on like, you know, to learn something where it's just sort of like, trust me, bro, or this is happening in the back end, without people telling you better how it goes, right? And so, yeah, so I think that's the thing is like Vulkan definitely harder to work with, right? But if I think about it, no, it was about 5 hours for me to get just like a shape on the screen with OpenGL. And then also, I'll point out, I didn't touch a single shader. I was able to just like display whatever I wanted in the colors without one shader, whereas on the OpenGL tutorial, I'm over here writing shaders that did nothing. They just like translated, they took the bits and put the bits. That was it. So yeah, I don't understand. I don't understand why that was necessary. Anyways, hey ZA2, welcome, man. Sadly, we are almost at the end of the thing, so but anyways, really fun. I highly recommend if you're like, I don't know, if you're like skittish about learning graphics. I don't think it's necessary to make a game. I'm just kind of having fun learning these APIs and thinking about them critically. But if you are interested in it, then yeah, go through that VK guide. I would say just take it slow. It's more complicated, but I think it's better explained. And especially if you're someone who comes from like a networking or database or web application background, I think Vulkan probably will make more sense. Even though it's very convoluted, it'll make more sense than OpenGL, right? Yeah, because OpenGL is very kind of like, yeah, like I said, it's kind of weirdly behind the scenes magic happens, and Vulkan is like, I request this from you, GPU. Complete these commands. You are done with those commands? Why, thank you. Which is basically a database, right? All right, y'all. That was a lot of fun. Is OpenGL at 4.6? 4 point something. I don't know. And also, from what I understand, the difference between 3.3 and the later 4s is kind of just more capabilities. I don't think it actually is like a major fix to the API.